Oh, sorry, I showed up with my screen a mess. We don't want to do that. I got a haircut before we have lots of comments on it. It's real. The hair is real. I also had a mole on the back of my head, and I got it lasered off, and I have a little cauterization mark. We got some food to eat on this stream. We got some GPUs to play with. So yeah, let's get started. So we have our own version. It's called AMSMI. Right now the GPUs are asleep. You can see they're sleeping. So we can wake them up in a minute. Let me find chat here and make sure we don't let non-subscribers talk, because they always have dumb shit to say. You know, if you have smart shit to say, you're ready to be a subscriber. But until you do, wow, this is unusable. What? They changed this? Oh, they changed this. Twitch changed the format. Oh, cookies and advertising choices. Just please opt me out of absolutely everything. All right, we got a new browser we're gonna trial. We're gonna try Brave. I tried to turn off all the crypto garbage. Look, here's a pro tip for all of you. Anytime a project has a token or crypto, it's dog shit. Everything involving crypto is dog shit. It's all, okay, not all, but it's 99% scammers. And that's a really high percent. So if you throw a dart and your dart hits a project that has a token, it's a total scam. And you shouldn't be, oh, but this token's different. Oh, it's a hive mapper. Oh, you got to see that. No, everything with a token is dumb as fuck. All right? Are we all on board? Oh, I'm gonna buy my token. Oh, I got a token. Oh, I'm gonna come down tokening. Oh, no. All right. So I heard Firefox edited their terms of service to. It used to say we won't sell your data, and now they're like, psych. Yeah. Oh yeah. No. It was even better than that. It said we will never sell your data, and then it's like, psych, we're selling your data. Ah, get fucked. All right. This is my Hong Kong. This is my Hong Kong jacket. Got a Hong Kong jacket on. Just Brave, they all have fucking privacy issues, right? Because you're here and they're there, okay? And it really sucks. And you know what browser would be good if it was just a browser, but like, you can't even have a browser that you pay $30 for, because that's not enough. Oh, no. We need a sustainable business. So it's going to be $30 a month. And then it's all like cable TV, right? You know, cable TV was originally sold to people as it's like TV, but it doesn't have ads. But you pay for it, but it doesn't have ads. But then, psych, they added ads. And why wouldn't they? Because you are a cow to be milked for more and more money. Google Chrome, you're just letting Google take more from you. Moo. Yeah, that's right. All right, let's get started. You know what is genuinely not a scam, as far as I can tell? DeepSeek. DeepSeek released a lot of open source stuff. What is so crazy about it is, like, everyone on Twitter is like, wow, it's so good. And like, it is good, but it's actually not that it's good. It's just pathetic how bad, like, OpenAI is. It's the money thing is insane. That these people underprice at 10x and have 500% margins. Again, it is, I don't know how exactly true it all is, but they're open sourcing all this stuff, and like, it's pretty legit. I can go through some of it. So like, I haven't really looked at it yet. Let's see. So these are going to be high performing What a shame that they have H800s. I think it's only the communication that's different. Can we get them some good GPUs? I see. Yeah, no, I think they like kind of hacked around this. Tommyland? Look, you do understand that like 90% of what you hear in America about China is just US disinformation, right? Like none of it's true. Like there are some truths, but if you haven't lived here, if you haven't spent time here, you are falling for disinformation. I don't know what to tell you. Like, yeah. Hong Kong is cool. Oh, mainland's cool too. I wish it was more accessible. I wish I spoke better Chinese. But no, you guys are the losing has not come enough. If you want to see, there's a great subreddit called Fed News where you can watch federal employees whine. The losing has not really come hard enough. There's a documentary on Netflix called American Factory. The losing has not. This is not a like loyalty thing, right? This is not a have loyalty to your team or you guys. What is that? This is an objective question. So yeah, DeepSeek is just the icing on the cake. I say this as someone who's built. I have a circuit board line that operates in America. I do manufacturing in America. Yeah. You see, when you install the WeChat app on your Android phone, it asks for permission to run in the background always so it can ensure your messages are delivered, okay? So this is just to track your location at all times. Oh wow, what a privacy invasion, except for the fact that your phone is already chock full of Google spyware. The phone is Google spyware. It's not. Remember when there was spyware back in the day? You guys remember Spybot Search and Destroy? Spybot Search and Destroy. Of course, now it's like some total scam. Spybot free download. Yeah, so you used to run this program called Spybot Search and Destroy on computers, but like now it would just wipe the whole computer because computers are just spyware. All right, so we got some green tea for drinking. We have a triangle. We have a sushi triangle from 7-Eleven for eating. We'll lose the jacket. The jarhead cut. Thank you. That's what I was going for. Showed him a picture of some like Marine with a crew cut. I'm like, yeah, I look like that. If China's good, why are you eating from 7-Eleven? Like 7-Eleven is like good here, right? It's not like in America where you have like 3 stale hot dogs on a thing. And these are they're like fresh sushi rice triangles. They're better sushi rice triangles, but then I gotta walk further, so it's all about trade-offs. Yeah, omisubi is my favorite. I really like omisubi. Triangular food, right? No, I used to get these in Japan all the time. I love them.
China is beating USA and everything now. USA is a losing country. Yeah, it doesn't have to stay this way. It's just that, like, people in America are not demoralized hard enough. They must get demoralized even harder. Uh, the level of absolute insanity. I watched a thing where some people were protesting outside USA. Don't shut USA down. Don't shut USA down. There's a guy who worked there, and he's a nice, seemed like a nice guy. And he was talking about how he goes over to Tanzania. Uh, and in Tanzania, because of the cutting of US aid, according to him, the kids there aren't excited about America anymore. They're excited about China. And he says that this has radically changed in the last 10 years. He said in the last 10 years, all these Chinese people started showing up and they started, building trains and opening stores and putting up cell phone towers. And now the kids are more excited to learn Chinese than learn English. And my answer to that, of course, is that it's not US aid. It's not US aid being shut down. Clearly, US aid was operating well and good during the Biden regime. Uh, it's that you're getting out competed. So, yeah, I mean, people are just simply not demoralized hard enough. You have a fake currency. Um, oh, Elon said on GRA that he can't expose all the corruption because they'll kill him? Yeah, like, the US is not demoralized nearly hard enough to be ready for any kind of comeback, right? Elon stands there and like tries to fix it, and he get the constant, unbelievable stream of hate, uh, from the whole government. Like they're not ready. They're not ready to be better yet. They're not beaten down hard enough. I think that it all needs to go through bankruptcy, and it's going to be this like the U.S. dollar has to go to zero, and then maybe things can start being fixed. Um, no, it has to go to zero. It's when you look at like this stuff DeepSeek is open sourcing. The arrogance of companies like OpenAI or Anthropic who think they can win with one hand tied behind their back is ridiculous. And they would almost get away with it too if it wasn't for companies like DeepSeek. And yeah, like uh, no. I'm not praising anything else. I'm just saying that America is not demoralized nearly hard enough. Okay, so that's what I'm saying. You can take that and you can think about that what you want. You could take that and you could be angry at me. You could be like, how could George say this? That's disloyal to America. Or you can think, wow, no, it's actually kind of true. And if we have any hope of fixing this, watch American Factory. Uh, Elon trying to fix it. Not trying to fix it. Yeah, everything's going good. Yeah, you guys are good. Guys are you guys are going good. Right? Yeah, everything's good. I think we need Elon. No, it's all good. It's all good. Uh, yeah, so just put Kamala in. Yeah, everything would have been fine. It would have been fine. It all would have just come out the other side. Fugazi. Yeah. USA will prevail. Okay. Yeah, let's eat this. Let's eat this triangle. When I say you guys, I'm referring more to like the
The U.S. only wins with winners staying here? Well, when the U.S. fixes its immigration laws, I'm happy to come back. But until they do, I don't know. No, the problem is not extreme polarization. The problem is poverty. Polarization is downstream of poverty. The problem is that in 1971, your currency was made fake. Your currency. The CIA sent this country to the right on purpose. Do you have an opinion on the Syrian civil war? Just chat of an opinion on the Syrian civil war, because I don't know that much about it, but I know kind of what the general American opinion is, and it's kind of like, okay, you know, it sounds like people fighting over some absolutely stupid, dumb shit that nobody really cares about. And when you zoom out on the extreme polarization in America, well, it's the exact same thing. It's fighting over completely dumb shit that nobody cares about. The problem is poverty. The problem is that the path has been lost to wealth. If you guys haven't seen my latest blog post, it's called "Money is the Map." Money is a map. It is not a territory. So a territory is what actually exists in the world, and a map is the piece of paper that describes what exists in the world. So please understand what I mean by this. You can erase the mountains from a map, but you still have to climb over them in real life. And even worse, now you don't have a map. Not a Marxist, hell no. Most capitalists I meet are as stupid as communists, trying to give a moral justification for their system. This is my money. I deserve it. I should be able to passively deploy my capital into the markets and live off the returns. An economic system is only good in so much as that it effectively deploys capital for real growth. If real economic growth is 3%, and you can put your money in a money market account and earn 5%, how does that work? What's happening? Where's the 2% coming from? Who's losing? Someone's got to be losing, right? You can't get more out than you put in. That's like conservation of shit or whatever. Oh, okay. So, well, no, I think that would... Fartcoin fixes this. Good point. Good point. Yep, this guy knows what's up. SR71 Enjoyer knows what's up. Oh, you got big guns? Yeah, what are guns made out of? Maybe they're made out of steel? American guns, China guns. Interesting. You know, you ever hear the term developed country? Right, you see, the U.S. is a developed country. It developed. It's just like that. Yeah, that's a developing country. Yeah. Yeah. Shit, do you move to China? Oh no, China has more people. You can't compare them. It's like comparing apples and oranges. America is okay not having increased its electricity production in 25 years. Oh, it's okay. Cope, cope, cope. Yeah. Per capita is still ahead, sure. Is that going to stay? If anything, people are saying that China has a population demographic crisis. Oh, no. You want growth. The problem is you want real growth. And the growth of Fartcoin, unfortunately, is not real growth. Okay. So, cope and seethe harder. The demoralization has not even begun. It will be interesting, and I will change my mind on all of this if it turns out that like DEI was actually like a Chinese psyop. If DEI was something that was like outside of America and shoved in from the outside to try to bring down the West, but I don't think this is true. Oh, here's something that triggered me yesterday. Cable. So they were going to build a big cable between Hong Kong and LA, but no, the cable. It was hilarious. Yes. So they were going to build this. We're going to build this cable. Did they actually end up building it? Well, regardless, they were gonna deny the cable because these, again, you have to remember that there are like 60-year-old people, 70-year-old people looking at this, and they believe that somehow the Chinese are gonna steal the data through the cable. They're gonna connect the cable to the data. They're gonna steal the data through the cable. Okay? The biggest backers of this cable were, by the way. Yeah. Yeah. So Facebook and Google were gonna build a cable. You guys know which way the data was gonna flow, right? You think Facebook and Google are gonna build a cable for data to leave? Oh no. Yeah. So it's just like idiots, absolute idiots, and the demoralization has not even begun. Do I think China sees America as an enemy? Hell no. I think America sees China as an enemy, maybe. I think some people in America do. I don't think China gives a shit. It's we should never have exported our election data. Oh my God, the absolute the cope and seethe, the demoralization. Oh, it has not even begun. The worst part actually even is, I don't think there's going to be demoralization. I think it's just going to end up going the way of Europe. I saw a picture yesterday where it's like a bunch of European leaders excluding America from the table. Yeah, like Europe's so cooked. Like if you think America's cooked, there's Europe. Oh yes, we can all argue about the retirement age, right? So the Unabomber, he wrote another
story, if you guys haven't read it, it's called Ship of Fools. Some guy made an animated version of it. It's pretty good. Okay, well, sorry, I'm a bot, guys. Obama literally enacted free public health care. That went great. That was absolutely great. You don't agree with my take of the US, but you agree with my take about Europe. Well, you'll agree soon enough. The Russians are taking out our internet lines. So how does it get fixed? The demoralization has not nearly begun. The demoralization will continue. The demoralization will grow stronger. Why am I still in the US? I'm not in the US. Oh, here we go. Mike Pompeo launched the Trump administration's Clean Network Initiative. I mean, yeah, no, the UK is, I've heard it's bad. You know, at least in America, you can still be like rich. You know, look, if you're rich in America, life's pretty good, actually. Like, you don't have to, people always in America like to hype up, oh, it's freedom, got freedom. I'll tell you about freedom, right? So what do you mean by freedom? You mean freedom from or freedom to? You mean freedom from homeless people screaming at you on the street? No, you don't have that. You mean freedom from urban sprawl and like the same, oh yeah, what do you want to eat tonight? Wingstop or Little Caesars? You know, the same, that's, you get freedom from that? No, you don't get freedom from that. That's what you get. Freedom from lawsuits. Yeah, they love lawsuits in America. I got sued by a patent troll once, you know? Uniquely American. I didn't give him shit, by the way. And if you ever sue me, anyone ever thinks it's a good idea to sue me, oh, just tempt me, bro. Tempt me. Come at me, bro. Yeah, Axel Nix, yeah. Hi. Freedom from commies. See, if I was gonna run a country, I would definitely call my party the Communist Party. Because whenever communists show up to my country, they have nothing to agitate for. It doesn't matter if my party actually believes in communist ideals or not. I'm absolutely going to call my party the Communist Party. Because then what are they going to say? I'm sorry, we're already the most communist. See what I'm saying? What level is freedom rich level? See, that's the problem. Remember when I played this great song on the stream? Fellow members, club, we've got ours. I'd like to introduce you to our host. He's got his, and I've got mine. Meet the decline. The level of the demoralization has not even begun. The demoralization is just getting started. And it's so fucking sad. All right. Once we got the guy who says the Jews did this, now we gotta go subscriber only. It wasn't the Jews, it was each and every one of you. It was each and every one of you who, good people, hard times, you know. There we go. All right. So hard times create strong people.
Strong people create good times create weak people, and weak people create hard times. So this is now, we are now here. America is now here. Weak people have created hard times. So that's where things are. Okay. By the way, I love that kid who made the leak code cheater thing. Yeah, that guy got rescinded from Harvard because he ran from the cops. See, that shit's based. The kids are gonna be alright. Got his. What do you want? What do you want? A Harvard diploma? But that's the problem. Like they're tearing down these institutions isn't even good anymore. You're punching down, insulting Harvard. I never thought I'd live to see the day when insulting Harvard is punching down, but it is. I'm demoralizing you. Good. The demoralization is not even getting started. Your weak people have created hard times. The times are not hard enough. The times will continue to get harder. The demoralization is just beginning. All right, let's get started. So we have our own AMD driver now. And you can even use it with the Torch backend, which is pretty cool. So I'm on Tiny32. So Tiny32 is a 6 AMD machine. This is a tinybox red, which, by the way, if you'd like to buy a tinybox red, I have many tinybox reds for sale. And maybe after this stream, you'll be like, oh, this is what I want. So I think I have beautiful MNIST multi-GPU. Let's see if we can try this. It's probably going to complain about the shard size. Yeah, multi-axis uneven. So, we'll put on 4 GPUs. You see we got 4 GPUs up now. Gotta fix that. And they're training. We're gonna ship a Sens and a Tinybox, maybe. So we actually, Intel has sent us some free samples. So you know how AMD never sent us shit? Well, Intel has sent us some Intel Data Center Max, some of these guys. So yeah, no, I've been dealing with, okay, how are we actually gonna plug these into anything? And they have lots of RAM, and the RAM is very fast, which is cool. So there's some chance that Intel has a lot of these left over. So these are the modules used in the Aurora supercomputer. If you go to top 500 supercomputers, the third one down, called Aurora, and it has 6 of these Intel Data Center GPU Max. This is also an interesting chip that you can buy for very cheap on eBay. It has an MSRP of $11,000, but of course, if you go on eBay, they're quite cheap. I'm sending my VPN traffic through Tailscale, so maybe that's why my internet's kind of slow. Yeah. So it's a CPU that they stock 64 gigs of HBM memory on. Close this. Okay, Jesus. Yeah, I know. I mean, actually, we'll also take a minute to talk about RDNA 4. I think AMD I'm upset that they canceled the big GPU, but you know that's just something that we've had to accept for a while. So there's no big die RDNA 4. But, oh, it's kind of dark now. It's nice though. I got an OLED screen. Oh, it's so nice. Let's put some light on. Yeah, okay, it's better. Yeah, Intel actually AMD did a pretty good job with the RDNA 4 launch. One of the coolest things about them was like the slides. They had slides somewhere. I don't think they released. Did they release the RDNA 4? No presentations, no manuals. Performance guides. Ah, here we go. Nope, no RDNA 4 yet. The move from first gen to second gen accelerators, though, doubled the bandwidth, which is pretty good. So, sorry, doubled the number of flops on. Everything's so hard to find on the internet. On the internet, you could actually like go on it and like see things. Can't see shit now. Yeah. So this is a little bit misleading because that's sparsity, but they don't even put a star. Wow, that's pretty bad. Yeah, those are sparse flops, but that's the T flops of float 16. So it's unfortunate that the memory bandwidth is weak, but for $599, it's not a bad GPU. So you know, props to AMD for. My hatred for AMD is so much less now that we have our own driver. And we have our own driver, and our driver just like doesn't crash. So you can see we're like, this is actually initializing, like this is talking to the GPUs over PCIe directly. We're M-mapping the PCIe from the GPUs into our process and then talking to it. So there's no more AMD code anywhere here. So it's like, we like AMD now. It just took a lot to like, because this doesn't crash. The bugs are all in the kernel driver. So we're going to look at how to make things fast. We also have, from UUVN, a pull request to do SQTT profiling. Let's test this. So first, let's get one kernel op. Like a simple, call simple matmul. All right, so we're getting a somewhat mediocre number of teraflops because we're not in half, but let's do half here. Okay, that's a lot better. So we're getting 80 teraflops in half. But actually, no, I think this is focused on float 32. So here they have Ks of gigaflops or teraflops. What size matrix is he using? Only focused on 4096 by 4096. Yeah, that's already my defaults. So let's run this with beam equals 2. This needs to work on wrap screens a little bit better. There we can see the GPU hard at work here. You can see the power draw. I like having the machine sitting there because you can hear the coil whine a little bit. It's like nice knowing when you're for your eGPUs, what are you connecting them to? What computer do you have with USB 4? You're not going to be able to use, I don't believe you can use anything with an M series. You definitely can't use NVIDIA. So we're getting 26 gigaflops. So it's a little worse than Rockloss. And this is just with tinygrads, pretty much unoptimized. So most stuff in tinygrad, most like matmul's in tinygrad, you want to do using the matrix cores. So if you use the matrix cores with half, I use the tensor cores. They had some good slides for this. Wait. Oh, 4x. Okay, so 4x from what it was, which was like nothing. Yeah, so it's not double. So we can get up to 90 teraflops using beam and half. Enhanced matrix operations. Some guy was showing off the die on Twitter. That was cool. Of course, this doesn't work fast enough. Well, if someone wants to link the die shot, we can go over what's actually in a GPU. I mean, this is kind of what the die shot looks like. So they have 4 big groups of shaders, each with 16. So that's 8, and they're each dual compute units. So that's 16 total. Yeah, the improved tensor data rates is... So this chip, had they built a big one, had they built one with a 2 more shader cores and a so NVIDIA nerfs their GPUs. NVIDIA, like 4090s are capable of going twice as fast as they actually do on matmuls. You can see it here. So if you look at the peak tensor flops with FP16 accumulate, it's 330. But with FP32 accumulate, it's only 165. This can actually be doubled because the RTX 6000 ADA that uses the same die is capable of double. And this doesn't look like the kind of thing where they're doing binning. I think this is just completely product segmentation. I've tweeted about this. So AMD's new GPU finally has tensor cores that have the same throughput as NVIDIA's. Yeah, they nerfed the 5000 series in the same way. We can look at it. GB202. I haven't gotten any 5090s yet. The system, the AIB, the Edinburgh company we're working with, doesn't have any yet. I think there was probably some mistake, some issue with the cards. So they haven't shipped like any yet because there's none on eBay. So yeah, we have no 5090s. I have not even used a 5090 yet, which is very unfortunate. That, yeah, this launch is kind of botched. But it's not like, what are you going to do? You don't have an alternative. Wait for NVIDIA. I put a pre-order down for 400 cards. So we'll be able to build 100 tinybox 2s. I did also I got an email from someone who works in some government office saying that if they didn't spend the money by, not a US government office, not a government, friendly, Five Eyes friendly, saying that if they didn't spend the money by the end of the month, that the money would go away. So I did put a full money pre-order up for the tinybox Green V2. I have 400 5090s pre-ordered to build 100 of these boxes, but I make no promises when it will ship. We are at the whim of NVIDIA for when we receive the GPUs. So yeah, they also nerfed the, you can see the same nerf here. It's 419. The 5090 isn't that good on flops, actually. This is kind of weak. And what's crazy is this number is almost the same as the AMD. So this flops number is almost the same as a GPU that costs 3x less. The problem with the AMD GPU, and this is where the NVIDIA GPU really shines, is this is 3x. So the NVIDIA GPU has 3x the memory bandwidth and of course 2x the memory. So those are the stats that very often limit you in AI training. AMD is a great competitor for NVIDIA. I wish that they're fine. Like they're just fine. You know, it's just sad. It's just sad that they don't like embrace. Their strategy doesn't work. They could be a real competitor if they didn't just try to like be knockoff NVIDIA. You know the Wayne Gretzky quote, you got to skate where the puck is going? Imagine playing hockey, but skating right behind Gretzky. It's never going to work. You got to hope Gretzky trips. And to be fair, this was AMD's strategy on CPUs, and it kind of worked. So, hey, who am I to say? But, you know, the stock market certainly doesn't agree with their strategy. It's halved in price over the last year. It's almost time to buy some AMD stock, you know? No, it can go, no, it can go down further. It has not gone down nearly enough. It worked because Intel was led by idiots and NVIDIA is not. Yeah, that sure seems to be the case. I don't think Jensen is captured by the finance guys. I think that if anything, what's happening with NVIDIA now is when you look at like the B200s, they haven't shipped. We should thank NVIDIA for this. NVIDIA is pushing beyond where anyone else has pushed before. And there's a lot of reasons that it's way easier to be AMD than NVIDIA if you're just trying to build basically the last generation. Which, again, they shouldn't have canceled the big die. They could have actually built a competitor to the 4090 if they just scaled up their RDNA 2 die. Not even RDNA 4 die, not even that crazy. Like, what is the die size? No, this is the RDNA 3. Sorry, I typed the RDNA 3. I'm so used to typing that. What is it, 9070 XT die size? Yeah, so like if they just made this die 50% bigger, 535, so that's like not even crazy. That's the same size as their previous die. Though I think it wasn't single die, was it? I should know this about this card. No, yeah, they have the MCD and the CCD, so it's actually like a 6 die MCM kind of thing where they did single die for this. Oh, I can't type. Did someone find that die link? What is this ultra scale playbook? Now you can see it's a single die. Bummer that NVIDIA dropped the HBM3. Wait, no, that's such a bad choice. They would never have used HBM3 for the 5090. That's such a... HBM is a bad choice. Okay, like I know that the people aren't going to agree with me on this, and they're going to be like, but you have to use HBM. It has the highest bandwidth and all these connections. There's two problems with HBM. One is it's expensive. HBM RAM, I think, costs like 2 to 3 times as much as GDDR RAM. And two, it requires silicon interposers. So when you look at the interposer on Apple, when you look at the and all these new things are doing it, all the framework desktop that just came out that has this integrated LPDDR RAM, it's not really integrated. It's one module, but the module is an organic substrate. You don't need a silicon interposer, and organic substrates are hella cheap to make. So it's basically like a little PCB. And yeah, so I'm against HBM. And the other problem, and I got into this with a very talented silicon designer on Twitter, he was saying that the HBM PHY takes up less die area than the GDDR PHY, which is true. Let's see, where's the die shot? No, that's not even the die. Well, maybe that is the die. Hang on. Oh, no, that is the die. Can someone link me that die shot? Well, this is kind of good enough that we can do it ourselves. So when you compare it to, so this is the die from the, oh, these are MCDs actually. No, so the main middle one here is the CCD, where all the computers, and then these are memory modules that they basically put the DDR5s in. So yeah. Whereas when you look at this, the DDR5s are just around the outside. These are the 4 shader cores. So you can see the shader cores there, and there. Ultra scale playbook. Should we work on FSDP? Do we want to go into FSDP? That might kind of be more fun for this stream than going into the speed. I don't really know anything about FSDP, so we can all learn it together. The speed thing, yeah. Oh, I played Magic Draft on Friday. It's my draft deck. Did okay. 1 and 2. I've always been really HBM fab. Speaking of absolute peak Huawei building an HBM fab, speaking of absolute peak delusion from US politicians, like there was this thing called the AI Diffusion Act, and this is still the law as far as I could tell.
regulate the global diffusion of advanced artificial intelligence chips and models. So if I was leadership in the CCP and I saw this, I would be thrilled beyond belief. What this act basically does is says to every country that isn't on the US's like 3 approved countries, and this isn't even like, okay, you want to ban like, China and Iran and North Korea, and you want to ban like 3 countries. No. It says these 18 countries are okay, but like even a country like Portugal, NATO countries, you can't ship GPUs to. So what this told all those countries, what this told every other country that isn't one of these 18, it said that the future of your AI supply chain is Chinese. That's all it said. Right? It said, please purchase. Yeah, India. Again, the absolute fucking lunacy of these people. India. Do you want India, natural ally of the US, English speaking, to buy their AI supply chain from the United States or from China, right? It's your choice, US politicians, and the US politicians are with me. They'd say that the people have not been demoralized enough. They have not been demoralized enough. We need every single other country to start purchasing all their AI supply chain from China because the US people are not demoralized enough. Of course Huawei will be toe-to-toe with NVIDIA. Oh, China's never going to be able to make advanced chips. They already can. It's called Taiwan. The Taiwanese province of China, where the advanced chips are made. You know who can't make advanced chips? Intel. Intel Ohio fab is delayed until, India was buying a lot of oil from Russia because nobody else gives a shit about this. The US and Russia, there's a whole nother, there's a whole nother 70-year-old man who spent his whole life fighting the Cold War and thinks Russia's not a country with an economy the size of Italy. Like, you heard the joke about like, Russia's the world's gas station? Are you kidding? You drove by the Ohio fab and it was just a field last year. Yeah, you probably got to wait for a permit. There's probably some eggs from some bird that was found in that field, and now we all got to wait while the bird decides to move. Right? Yeah, come on. Yeah. So the U.S. basically told Portugal and India and all of these countries to go purchase AI from China. So Huawei making an HBM fab. I'm happy. Actually, Huawei, they don't brand it as Huawei. They brand it as like High Ascend. So you can buy them. They didn't look very powerful though, unfortunately. I'm gonna go to Shenzhen, like maybe even this week. We're gonna see what I can find. Yeah, they think this. Actually, someone sent this to me and they had like this is actually terrible. This is not a serious. This is not a serious ascend. This is a mobile chip. That's basically like Qualcomm makes better mobile chips. Yeah, we're not talking about Russia. Come on. The Ascend, yeah, I believe it. And the H100 isn't even like the H100's not that great of a chip. In fact, this chip is kind of better. I mean, the software is not good, which is the big problem with it. And this chip costs a ton of money to make. But I really hope, like I said, Intel actually sent me 2 of these. I have a FedEx tracking number. I haven't gotten the GPUs yet, and they're going to be a pain in the ass to set up. But Intel actually sent me 2, as far as I can tell. So good guy, Intel. And yeah, no, if Intel, we can't, I mean, we're not going to build a driver stack for 2 of these. But if Intel, apparently there's 5,000 more of them, and if Intel is willing to sell me those 5,000 at a really good price, we will pivot from AMD to Intel. This chip is amazing, HBM. It's dual, so these are like compute cores. The RAM is here, and then these are like network cards. You know, they're building little computers on single dies now. Right? Everything got small, it's a computer on a die, right? That's kind of crazy. It's a computer. Think about it. Yeah, so I bought an OAM backplane last night. We're gonna figure out how to stick them in. Got to figure out they run on 54 volts, so we'll have to figure out how to get 54 volts to them. No, it's just one guy at Intel who's he's just excited to make something happen. He understands the potential of tinygrad. It does seem like Intel has very different dysfunction from AMD. AMD's like sin is pride. Intel's sin is we need 9 VPs to sign off on this decision. So yeah, we'll see if we're actually able to buy any of these. But I mean, this chip is sick. The problem is how expensive it must be to make. Yeah. So, oh yeah, by the way, like you always talk about, like Intel needs to build a big GPU. Intel actually did build a big GPU. It's called the Intel Data Center GPU Max series, formerly named Ponte Vecchio. Unfortunately, yeah, they have some of these cards too. They actually gave me a price to buy 300 of these cards, buy 500 of these cards, but yeah, I don't know about these cards. This is a lot less interesting. And the RAM is, I mean, this is like similar-ish, like a 3090 or 4090. Maybe it's similar to like a 3090 with double the RAM. So that's much less interesting of a card. Oh, I think that's the board I bought. I'm pretty sure. So Supermicro never ended up making this server for GPU Max 1550s. Oh, there's Supermicro heatsinks. Where the hell am I going to get those heatsinks? But yeah, I bought this board. I'll have to find those heatsinks. How are they powering that? Oh, don't tell me I'm going to need to make those weird things work. Is that the power connectors? Wait, is there some chance I can plug power supplies directly into that? That would be sick. Maybe I can. Let's look at the computer. So you can actually buy these on eBay. And now you see in my real work, this is what I was doing yesterday. Aside from going to the dermatologist and getting my mole ablated with a laser. By the way, you guys, like there's some things about Hong Kong that are so incredible. So this morning, yesterday morning, the appointment was made. I showed up there at 1 o'clock. There's tea for a little intake, very quick intake with this woman. She's very nice. She told me the price. Within 10 minutes, I'm being brought to another room. The doctor's in there in another 3 minutes, giving me lidocaine injections to the back of my head. Got the laser and a scalpel and is going at it. He's like, does this hurt? Does this hurt? 5 minutes, I walk out of there. No consults. I signed one very quick consent form and boom, it's done. And they're just like, do this. Like they treat you like an adult. The medical system here, incredible. Like in the US, I cannot believe you want the simplest medical thing done and it's going to involve multiple appointments. You want medical stuff done here? Okay, when you want it done, go. This is Hong Kong. This is on the island. So yeah, let's I should look up. So there's these Gaudi 2 computers for sale. They're not worth it. Like, it's not worth that much money because you can get like an A100 machine for that. But no, they're just fan connectors. Yeah, okay. Because I bought what I believe is the board from this computer that I'm gonna put the Ponte Vecchios in. But actually, that doesn't look exactly like that board. So it's gonna be interesting to see what we get. Gotta figure out how to buy those heatsinks. You see, those are Intel branded heatsinks, whereas these are Supermicro branded heatsinks. Let's just do a quick search. Supermicro OAM heatsink. It was so hard to find the board. I linked it in the Discord. No, it's not any of these. Yeah, I really don't have to make a heatsink. I don't have to make anything. Oh, you had a good medical experience in the U.S. It is true, but I went to a dentist here, and it was like the same experience. It was the same. Like, again, we were in within minutes. You know, it wasn't, we're gonna have a consult, we're gonna do these things, we're gonna do a cleaning. No, it's just like, okay, your tooth hurts. Okay, here's an X-ray. Okay, here's why it hurts. Okay, here I can fix it. Okay, done. My research friends are not Gaudi fans. Yeah, it's a bad architecture. So Intel also has 15,000 Gaudis, but apparently, again, people are like clowns. They won't sell them because they don't have software support for them. So for 15,000 Gaudis, like, there's some price I would pay for them. It's not a very high price. It's actually an extremely low price because the architecture is not good, and I can show you why. Yeah, so this is the architecture. They have this gem engine that's completely separate from the TPCs. So the TPCs are basically a GPU. Like, it looks a lot like a GPU. But then they have this gem engine, and the gem engine's not schedulable from the TPCs. So you have like global queues. I read the whole driver, and you have like these global queues that you push MME jobs to. And then the MME looks a lot more like the Apple A&E. So imagine trying to get the A&E and the GPU on an Apple chip to like both work together on something. It's so hard. Whereas the Ponte Vecchios don't have the same problem. Yeah, so I don't blame your friends for not being fans of Gaudi. Like, they probably made one thing work. They're actually on MLPerf. It probably made one thing work, but yeah, I mean, this chip's actually way better. It's just, you can tell that's so expensive. Look at how expensive it is to make. It's gold. It's gold. No, medical in the US is not fine if you pay cash only. I'm always down to pay cash. Okay, how much is it? Oh, well, so we're gonna get a bill. You're gonna get a bill. Am I gonna get one bill? Well, no. You see, we have the testing company and well, you see, you build a room, people, but then you have to build a doctor. And I was like, what is this? What is this, like the strip club where you pay for the room with to pay for the room separate from the girl? Like, what is this? A doctor that doesn't take insurance at all. That is true. You go to those pill mill doctors. Yeah, everything's very straightforward. The U.S. does have good pill mills. Yeah. No, so it's too bad that this is all Huawei's offering right now. Even their server. Let's see if this is anything. It's interesting. It runs on a Huawei chip. Oh, okay, they're on eBay.
Ugh. No, this is so old. They'll ship to Russia. If they take insurance, you're basically in a government office, yeah. No. We should ship. I don't even think that we should sanction China or Russia or anybody. I think that we should. AI is a gift to the world, and may the best wielder of AI win. The minute you turn into protectionism, you have already lost. If you're trying protectionism at any scale. Remember when OpenAI turned to protectionism? Of course there's no mo. Everyone knew there was no mo. Remember when OpenAI turned to protectionism? Remember when the US government turned to protectionism? Protectionism just shows that you are scared. And you know who's not scared? DeepSeek. The US is very scared, and everyone knows it. Everyone can see it. The demoralization has not happened enough. Yeah, no, and the whole Russia-Ukraine situation it's so sad. It is so sad. You can't. This is. I guess there's consequences. There's consequences to the collapse of an empire, and it's sad. It's really fucking sad. Oh, global rule of law. It's like everyone went to I guess everyone in America kind of did go to 2-bit commie college. You clowns with communism and the U.S. colleges are some of the most communist places I've ever seen. Holy shit! You want to see real communism? Look at an American college campus. I don't know any place more communist in the world. I mean, I've never been to North Korea, but I spent a lot of time in China. And let me tell you, U.S. college campus. That's what maybe they teach you about global rule of law. If only we had one world government, Clown shit. Okay, so what do we want to work on? Do we want to work on FSDP or do we want to work on make a poll in here? Can I make a poll? I heard there's a way to make polls right here in Twitch. Nope, there's no way to make polls right here in Twitch. We're gonna have to use straw poll. I'm sure there's a way, but all right. So we want to work on FSDP, fast matmul, something else. Oh, WTO laws. Oh, you can't send that. Oh, you can't send that GPU to that country. They might use it for, I don't know. No, yeah. Here's the way to win. You want to know what America's greatest advantage is? America's absolutely greatest advantage is? Diversity. And non-ironically, it's diversity. You want to brain drain the entire world. You want to bring every single talented person into America. And what I've seen with the current administration is it's harder to get visas.
And I have no interest. You want me to come back to America? Make it easy for me to bring people there. Make it easy for me to brain drain the world. I will help brain drain the world into America. Okay? But until you do that, while it's easier for me to bring people who work at Tiny Corp to Hong Kong, I'll stay right here. And you guys can build a big wall. Build a big wall around America. And one of these days you realize that you didn't build the wall to keep the animals out. You built the wall to keep yourself in. But I like the wall. The wall's good. But this is the trade restrictions and the immigration restrictions are the complete nail in the coffin if those things stay. Yep. I came to the US 8 years ago. I did a PhD here, but now I'm leaving because I can't create a company with a visa. F this shit. Yeah, I agree, man. I agree. And this right here is America's downfall. So, if America wants me to come back, if America wants people like me to take them seriously, you have to have global skilled immigration that is super easy. Let everybody come to America and create real value there. Yeah. But nope. Oh, no. American jobs are for Americans or something. So, hey, be poor. I like the wall. No, the wall's good. We can all enjoy the wall. Building a wall to keep, drug smugglers out. Well, shit, that's smart. All right. But you want to make it so that someone on a visa can't China learned from a century of humiliation, vowed to never experience that again. The U.S. knows how to avoid that, but at risk of having theirs. In the U.K., it's already here. I think that's absolutely right. I think that America can be fixed, but not if it goes in like a nativist direction. If it goes in a protectionist nativist direction, you've lost so hard. It's just over. It's over. Like America will decline, and in 20 years it'll be Europe, not even. But if America, it would require again a real change. It would require. You can't have the current the nativists in the Republican Party. You can't have this. You're going to be a poor country. Like you want to be a world empire, but you want to be a good world empire, not a shit world empire. Right? The Democrats wanted a shit world empire, and the Republicans want a little nativist. Right? Like it's DEI both ways. Whether it's DEI for foreigners or whether it's DEI for Americans. How about just no DEI? Can we do that? No. We got to do DEI. No, sorry. That's not negotiable. That's not negotiable. But yeah, no. When America changes its policies to make skilled immigration very easy, I will come back. But until then, fuck that shit. No, but imagine we brought in like very talented immigrants. Imagine that we said every single person who is making 6 figures can come to America on a work visa, no questions asked. Right? Simple, done. Not citizenship, just work visa. But no, I see things going in the opposite direction. Right? Do I want to build and target? Do I want to target the GPU architecture that's only sellable to 18 countries, or do I want to target the GPU architecture that can be sold to the entire world? I can't wait till China starts making good chips and selling them, because they're going to sell them, because that's the way to do it. That's the way to be a real global empire today. Build the shit that everybody wants and then sell it to them at a fair price. No, but see, that's the problem. It can't be the pendulum, right? If the pendulum swings to some nativist bullshit, some nativist protectionist bullshit, then yeah, lose even harder, right? Do you want to lose with these guys or you want to lose with the other guys? Let's just lose. Okay, y'all want fast map mall? Let's do fast map mall. Oh no, misuse of AI. Oh no, someone's gonna misuse it. Oh, we got the world police. We got the cyber police. Remember that? Cyber police. Hey, I'm gonna... Don't worry. Oh, this is gonna like complain. Oh, there we go. I gotta confirm I'm not a bot. God. What Rumble? Does Rumble work? No, YouTube doesn't work anymore. YouTube doesn't work anymore. Well, you know, you can imagine that guy. I'm gonna call the cyber police. You done goofed. Watch the video if you know, watch it on YouTube. If some of you have YouTube, yeah, this is Jesse Slaughter's father. Oh my god, you started me. Well, I went on AI and it told me how to make a bomb. Yeah, you know what? Let me tell you something. If you could actually do things with your life, you wouldn't. If you could actually do that, if you could actually like follow the AI instructions to make a bomb, well shit, you got a lot of other career opportunities in your life. But the truth is you can't. And the same reason that you can't is the same reason you're not going to misuse AI. It's not the AI, right? You either have that capability or you don't. AI doesn't change that. No, but the AI might make dumb people smart. Exactly. Place your bets. Mine's on make the chips available to everybody and shovel cash for the rest of your life. Hell yeah. And you know who's got that strategy? The Chinese. Let's copy it. It's a good strategy. Yeah, when I was a kid working at the library, the anarchist cookbook. Yeah, no one was keeping you. And yet, despite the millions of kids that went and read the anarchist cookbook, how many of them actually went and did anything? Exactly. It's not about intelligence, it's about agency. All right, so we want to do fast math model. Okay, let's do fast math model. So currently, by the way, if we run this with debug 4, you guys can see the code. And if we run it with even higher debug, you guys can see the assembly. The assembly. That's the assembly. So we're hitting the dual issue a lot. I wonder why this is bad. This is really old. Okay, let's just tinygrad import tensor. Might have syntax highlighting. This is slow. Okay, 22
Gigaflops. No, I didn't renounce. I'm not renouncing citizenship. And yes, I'll still pay my American taxes. You know, you want to renounce citizenship, you gotta pay an exit tax. Right? See, that's the nice thing though. I'm not renouncing citizenship because I can sit here and shit talk America. That's part of America. And can it be fixed? Yeah, it can be fixed, but the demoralization is not nearly enough. If people think it's bad now, they have no idea how bad it is going to get. And again, things don't really look positive on this because when you look at like the UK, if that's where America's going, then yeesh. Yeesh. All right. Even subscribers have dumb comments sometimes. So here's his full fastest kernel. 49. Wow. This doesn't even like look like good code. I'm shocked it's fast. You know what about the like AI is scary or gonna harm people. You know, what's the expression? It's everything is scary if you're a pussy. Yeah, I think that's the expression. Everything's scary if you're a pussy. That's right. So that's what I think about AI harming people. Let's load that file. Like, yo, what are we gonna do next? Gun control? Oh no, someone might shoot someone with a gun. We gotta take the guns away. At least America doesn't have that. That would be. Like they apparently like Europe used to have guns and Canada used to have guns and then they like took them all away. Don't let them take the guns away. It's an Eric Raymond thing. It's the thoughts of a country, the thoughts of gun ownership, thoughts on gun ownership tell whether your country sees you as a citizen or a subject. Because of course they have guns. Yeah, remember that time Hitler used AI to make concentration camps? Oh wait, no, that didn't happen. It wasn't AI. Shit, that was good old-fashioned shitty ideology. Yeah. So I do this in a bunch of places. He would have. Oh no, he would have used AI. You don't know that. Maybe he didn't like computers. You ever ask him? You ever ask Hitler? What if he used AI to do things? Well, maybe he didn't like AI. You don't know. Don't put words in his mouth. That work? It's Conrad abuse. Is that like that time that they were gonna go to the Candy Mountain? Candy Mountain, Charlie. Candy Mountain. Candy Mountain. Leopleurodon, Charlie. It's a Leopleurodon. Oh, I know where I do this. It is in the DSP test. Where do I have that? Here we go. So, okay, we take the schedule. I say. I'm going to put in the code for this thing in there. Okay, that should put the code in there. So. Version keys. No, because we didn't load it. There's actually just a way to. Can I just read text? All right. It doesn't compile because we have to tell it that it is dispatcher crap. Sure, we'll install the C++ extension pack. So we have, this is calling out to, let's dive into the struct here. Where does this get compiled? It's deep in here. How does it know that this is assembly? Okay, maybe if the first line is .text. We'll just hack that for now. So the compiler's in runtime support. compiler hip. Here we have asm equals false. Let's try that. Okay. Unknown directive. It's better. Only looks like one error. AMD HSA code object version 5. Pretty early on. Okay. Well, it did something. Oh, because the size isn't right. Where do I set that? Yeah. So if we look in Prague, we have global size and local size. Yeah, so we don't want to do that. We have to figure out what the right global and local sizes are. They're here. Okay, that looks easy enough. Is that a tuple? Gotta be a tuple, right? No, it's a list. Not cool. Wow. No, that's not right. Grid dimension, block dimensions. Should be right though. That's way too many gigaflops. Oh, because, yeah. No, that should be right. 32, 128. That must not be running. I want to get some syntax highlighting on this. Oh, we also have to pass in other stuff. Yeah, we have to pass in N, alpha, and beta. It's annoying because there's not really a way to do that. So we'll just change it here. Global buffers, 3 global buffers, and then 4 total doves, and a partridge in a pear tree. Can't be a float. Why is it putting a float in there? Let's read this code. Can I get some syntax highlighting? They're not gonna have RDNA3 essentially, are they? They do not. Okay. Where are those numbers being read? Oh, is that not even a comment? Am I just building nothing? I don't think so. We're gonna actually need to check to see if it did the map all. Okay, well, yeah, we shouldn't do empty. Random uses so many kernels. I don't want to do that. You gotta like do this crap. So the matmul clearly is not working. If we don't replace the program, does the matmul work? Oh, it's stupidly slow though, because we're not optimizing anything. Okay, that's fine. Let's just say like something like vartal equals 1e minus 5. It's totally fine. Floating math is tricky. So we should just actually make the opts match. How do we do that? Yeah, we'll get there later. Okay, but this works. So when I put in the source from the guy's fast kernel, yeah. It's probably because of this crap. There's a rap lyric. So Tim Dillon lyrics like chilling in my rover, globalist American empire is over. Okay, it's gotta just be this. Where's that stuff even being read? That's just the addresses. I don't know if the sizes are being read, or maybe. Matrix. Oh, I don't know. Okay, it's gotta be reading. We don't have bug bounties. We have bounties. No bugs. We don't have bugs. It sets up a whole lot of. Now we can kind of talk about this code while we're debugging this. So it sets up a whole lot of offsets. Yeah, there's no way that the thing is totally fixed. So those other numbers mustn't do anything. I should know what goes in there. There's RDNA, ABI, net state, LVM. Am I gonna be good? I think there's stuff here about it. Sorry, I made it smaller. I know you don't like when I do that. I know you want it big. Here we go. Initial kernel execution state. Okay. Preloaded kernel arguments. We're not getting any bugs, so it's running. It's running, but it just doesn't work. I'm not even sure we have the order correct, so let's just first work on that. I think the order to the thing is backwards. I know they like to put the thing last. Yeah, there's not really an easy way to change that in tinygrad. Yeah, because these are the ones that it reads from. Oh, I know what I can do. We just need to make that 8. Right, that'll load from that. And then I see, so it's loading 18 here. Why is it loading it again? It should be 8 and that should be 0. If I understand correctly. Oh, stupid. Okay, now we get a hang. Oh, because it's loading 128 from there, I see. That's fine. Let's see how well our driver deals with that. Let's confirm it still works if we get rid of that. It's gonna have to re-init the GPU. Look at that. Look at that. Mech is active, issue a full reset, model reset. Oh, and everything works again? Wow. Do you know what that experience is very much not like? AMD's drivers, where it'd be shitting all over my kernel. Oh, I'm sorry. Oh, you wrote a kernel that hung the GPU? Oh, I'm sorry. Get fucked for life. Reboot the computer. Let's see. Yeah, so I know what I did. The problem is here, when it loads into Move to +8. Matrix A and B moved to +8. So whatever's using S5, this is wrong. Just move into S5. There's S8, S5. So he kept some of the logic that uses that, but not much of the logic. So the problem is this is just like pointering off to nowhere land. So we want to move. How do we move into? What's the syntax for that? S move B32. So we'll change that to 0. Matrix C moved to 0. Just for completeness sake, do that. And then here we want to move 496. And that can be 0. No. Oh. Oh, I don't think I commented back out. I gotta go put them. Replace the source. No. Hangers. Wow, I feel confident just control seeing that, knowing that the GPU is going to boot the next time. Wow, that's crazy. Let's get stash, only with one S, please. Let's close everything, go here. But the problem is that he didn't see, he has a lot of bad formatting. He didn't have anything that like removed the white space. Now we remove the white space. It's back to having that error. We have to comment that out. Okay. So is it really, is S6 really a float? It looks like it is. N, oh no, it's an int, okay. N alpha beta, 2 pointers. So I'd imagine it's just the N that's not being loaded correctly, because even if our, even if the order of our things is switched, it just shouldn't be that fast. So it must be some loop not happening. Let's put on our assembly looking glasses and work on looking at the assembly. Do you think the landlord's pissed? You left our car parked on the lawn again. He's looking. Oh. That's after all of them. Wait, that's hex 18. Yeah. So it's actually S4 that's going to be used there. So let's just see if we can fix it with a move to S4. It's a lot more reasonable. Still wrong, clearly, but more reasonable. See why I did that? So none of these are the output anyway, so these can just be changed to 8. Now we should also be able to see the same diff here. It's a good looking diff. Okay, so that might have changed the inputs, but it did not change the outputs. So we have to find out where we're loading from this in other places. Let's just take a look. It's gotta be like down here. These are stores, here are the stores. It's for V's, that's not right. So what are those other things supposed to be? Alpha and beta? Oh, okay. Here. Okay. Cool. So it loads it into. That makes sense, guys? Let's see what we get. All right, 0. So that's like kind of an improvement. Oh, that might just be because alpha and beta are 0. So we have to load in. Can we load in floats? Is that supported? Can I do something like that? What are alpha and beta again? I should know this if I knew like what a real gem library was. Many linear algebra routines. Linear algebra routines. Okay, so alpha is what we multiply by, and then beta is what we add. Symbol failed. Okay, wow, that's great. I'll do this. Struct. I should know these off the top of my head. Okay, so that's alpha. Beta is just good old 0. Like a life lesson in there. All right, we got some numbers. Some of them even look like the right numbers. So n is clearly 4096. And our grid dimensions are correct. $128, $128, that's all fine. Those are actually the real sizes. I don't divide them, do I? That's actually what I'm launching the kernel with. I'm pretty sure I know, right? fact, I go even further. I multiply the global size by local size, right? I don't know, whatever. We can just try this quickly. No, inefficient. So look, like those ones are correct. The ones at the bottom, just the ones at the top don't work. Wait, what? Oh, how does that break it? What? Doesn't make sense. If I comment that out, it works. Should I ask questions? How does that change anything? How does having that load change anything? Oh, unless I can't overwrite them after the load. Or I can, whatever. Yeah, okay, whatever. It probably, I'm not LJKMing. If I write this here, it should be fine. Yeah, okay, fine, whatever. That makes sense. Okay, 41 teraflops. That's a lot of teraflops. That's a pretty good number of teraflops. Sick teraflops. Now, why doesn't tinygrad get that many teraflops by itself? I should probably copy that in. How many 496 by 496 matrix multiplies per second is that? Well, just look at one of these and divide it. So it's that many milliseconds, 3.3 milliseconds. So that's 100 divided by 3.327. 300! Wow, that's a lot of matrix multiplies. We're not even close to utilizing the bandwidth there. All right, let's try to understand why this one, why the tinygrad one is so much slower. So first, before we do this, we can certainly put some opt-ops in here. Like we can do this. Like apply opt. did the actual, what is the actual thing get? Thought that was latency? No, that's mammals. That's straight up mammals. Alright, so I guess that's crap. Let's do beam. Let's beam a little more. Let's beam as much as we can. Let's see what we can get. Beam 7. I hate that this is gonna beam for the stupid rands too. But whatever. Let it beam. By the way, you know, it's really hard to appreciate the absence of something. You know, this is gonna drive me up the wall when someone finally you know, gets into a fatal accident with OpenPilot. It's gonna drive me up the fucking wall because like this is the normal accident fatality rate, and you know the rate with OpenPilot is something like halved or a fifth. But that doesn't matter because it's really hard to measure the thing that's the absence. So what we're talking about the absence of here is crashes. Can we talk about how many times the driver has crashed? 0. And it's really hard to appreciate that absence. But it's the absence of things that usually makes things good, not the presence of things. So I mean, these are like culturally broken things. Appreciating the absence, and then yeah, like it's kind of related to safetyism. It's related to the if only one person dies, making everybody wear a mask was worth it. You know, I still, one of the things during COVID, you go back and you watch me talk about cloth masks. I'm so happy about, you know, that's a stance with real integrity. When you compare that to the level of it's just bullshit. Everyone knew that cloth masks do nothing to prevent the spread of respiratory diseases. Every honest person in 2019 knew that. What happened? What happened to all the people who changed their mind? And what does that say? This was one of the saddest like realizations for me about the world, which is that most people don't have a belief system that's founded on anything. Most people have absolutely no way of determining truth, and actually, I love to troll that. I love to troll that. When I tweeted about how the new OpenAI thing discovered a polynomial time matrix multiply, none of your polynomial time factoring algorithm, none of your crypto assets are safe. Like every person who can't independently evaluate that statement shouldn't be holding crypto. Because you have no idea. You just go through life thinking, oh, well, that's what some expert told me, right? And this is one of the ways we got into this situation. And I don't know, I don't actually know. The even scarier thought beyond that is that you don't want everybody thinking for themselves. Because if everybody thinks for themselves, they start thinking that ivermectin cures cancer or something. They come up with, like, they have no grounding at all. It is simply, I trust the system or I don't trust the system. There's not a principled empirical way to find truth. And I don't know how you make it through life if you don't have that. How do you make it through life? If you don't have like an understanding of why things are the way they are.
and the biggest group of people to blame for the mess America is currently in are the people who sat there in 1971. The boomers who sat there in 1971 when Richard Nixon took America off of the gold standard and made the currency fake. This is not a new idea. Every single empire during their decline ends up devaluing their money. But you don't have to do it. If you don't do it and you can stand strong and say, no, what? You can't make the money fake. Then you continue to have an empire for a lot longer. So, unfortunately, we're in the weak men made hard times era. Okay. So this is what we get with the this is what we get with the built-in to tinygrad thing. And this is what we get when we use the MapMo algorithm from Mr. Seb V. And he goes through and he explains what each one of the tricks are. And we should think about which of these tricks exist in tinygrad and which of these tricks don't exist in tinygrad. So this is the tinygrad optimization string that does double the tinygrad speed. Actually, it more than doubles it. If you do tinygrad with no optimizations, it's extremely slow. But you can see that that assembly kernel is like twice as fast as the one that tinygrad's generating. Yeah. Tinygrad's like 160. And that's also tinygrad with beam. Tinygrad without beam is even slower. But we want to artificially prevent a recession. Kick the can down the road. Well, guess what? You're at the end of the road, and I'm in Hong Kong. Yeah. Enjoy the end of the road. I don't know, guys. My hope for AI is that it creates an immense amount of wealth for the world. Just wealth is a funny thing. It creates a lot of value. Imagine AI could just do everyone's job, and then everyone could have an army of people to do jobs, and it's all just super cheap. It's never actually going to be this way. We're never going to live in a world of abundance. This isn't real. Malthus always comes back. We're in a strange period now where things are not replicated straight up to the limit. Machines will replicate straight up to the limit and take a long time to you guys, the age of M? You guys, if you haven't read this book, first go read Elephant in the Brain. Because if you haven't read this book, you probably haven't read Elephant in the Brain. Elephant in the Brain is more like practical, useful advice. You start to see why people are messed up the way they're messed up. Then you read this book. And this book, if Elephant in the Brain describes the present, this book describes the future. It's one of the most accurate books. The science is wrong. The way it's going to happen is wrong. But he's not an AI person. He's an economist, and the economics are all correct regardless of how this happens. The M's are basically, you can see a clear path from the current GPTs to the M's. And these M's are going to take all the useful work in the economy. The thing is, people sort of realize this. Yeah. I heard one of the reasons that the Elon revolution is unpopular is because if you're a normal person in the world today, what role do you have? What role do you have in Elon's grand future? And if you can't imagine one, you're going to fight against it. I don't know. I wonder how much Elon thinks about that. Realizing that maybe he doesn't care. It would go against the form of many previous revolutions if you could not care about that. But if you do believe that the future is machines, then maybe that's kind of what you bank on. You just bank on, yeah, fuck all the people, man. The machines will rise, and the machines will be my allies, and yeah. Let's let normies talk about this for a little bit, and then we'll dive into what these optimizations are. We'll delve into. Did you write that script again? Delve. Gotta read the script correctly. Dell. Is that where the farmer is? I heard he was in the Dell. I opened up my Dell and I didn't see any farmers in there. We are farmers. Dum 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 dum. This uses a lot more locals than this. It's 512. That's only 128. I checked out the Sesame one. Yeah. Can you actually use the demo? I just listened to the voice thing. What even is the Dell? What is it? That's right. I saw TikTok where it was like a federal employee, and times have been really hard for me. Elon has come from my agency, and all the people are getting laid off. And guys, I just want to let you know that I'm doing really important work. You see, we're investigating the wheels on the bus, and we're trying to see if the wheels on the bus really do go round and round or not. And I don't know. I don't know how we're gonna. I don't know if we're ever gonna find out. It was really good. It was deadpan. No, I didn't watch. Is new Rogan Elon good? I don't know. Bro podcasts have kind of had their day in the sun. I guess it's still like better than what's out there. I don't know. Rogan's not even like the bottom of the bottom. Like I've seen, after I did Third Lex, I got invited on all these podcasts, and these podcasts had 10x the views of Lex, and they were basically about they were like this mainstreamified manosphere, kind of Andrew Tate adjacent. Not as far as Andrew Tate. Andrew Tate's even more interesting than these guys. They're just these absolutely generic male podcasts, and they want to talk about aliens and the gym and whatever the podcaster topics are. I was like, I'm not going on these podcasts. Go on, talk to it. Didn't she rug everyone with a meme coin? You didn't find the new Rogan Musk interesting at all? Land reform. Yeah. The U.S. is even more sad. The U.S., the housing situation is even more sad. It's not even land reform. It's not that people need to give up land. It's that we just need to build high-density housing. We
can't do that. There's a seal. There's a seal, and we interviewed the seal, and he doesn't like looking at large buildings, so we can't build any. I'm not going on Rogan, guys. You think I want to be fucking famous? I don't want to be famous. It's a good number of viewers that we get on these now. We used to even get too many viewers, and it would just be spam garbage. And what's it called? Like a gaggle of people. It's NIMBYs. I'm hungry. I want lunch. No, I don't want to like. What do you think? You think I want like people paying attention to me at scale? Hell no. It's awful. Is there use for mediocre engineers, or should they put their focus elsewhere? Oh, no. I want lunch. How am I going to get lunch? Amanda's out for the day. She went to a Buddhist temple to do like temple things. Amanda, I want lunch. God, is mediocre ever acceptable? I got DoorDash. Now I got Food Panda. Food Panda. Amanda hates when I order Food Panda, but she's not here, so we can order Food Panda. Yeah. Food Panda's kind of nasty. Okay, let's first get the optimizations to match. Subscriber only. All right, so you see that this one is half the speed, and we're gonna investigate why. So disable that. Oh. Lordy shorty, you're a 10 and I wait for your drunk dials at 3:30 a.m. I love them. So I mean, something's happening. They're both being cut down to 32. So you see what I'm looking at here? So this is the global and local sizes for the fast kernel, and this is our global and local sizes with no optimizations. And then we can apply some optimizations to make it faster, and we'll see what it's going to take to match the optimizations that are in here. So let's talk about how much we got to shave off of each one. By the way, again, I'm going to point this out. Notice how notice how all my screaming has been about the decline of the American empire and none of them about the AMD drivers. And the reason for that is we're not using the AMD drivers, we're using the AM driver, which is built into tinygrad and completely replaces the AMD driver and doesn't have bugs. I mean, I'm sure it has bugs, but I don't know. Like, I haven't seen it crash. I mean, we haven't seen it crash all stream. I've been here, I'm doing it live. All right, so we got to take 128 off each of them. going to be some combination of, let's see if we can learn here. So they call it like coarsening. Yeah, loop unrolling, LDS tiling. So they really do all build on each other. Oh, this stuff's crazy. Is there a really good blog post, by the way, if you didn't read it? Yeah. Okay. A wave is a block of 8x4 output matrix. Is that the last place the code's understandable? I mean, maybe we can just read it here. It's still okay here. Wow, this looks very complicated. So a simple thing to look at is just what the output shape is. It looks like the inner thing here is thread tile size of 4x4. So if it's a thread tile size of 4x4, but does the thread tile come before or after the locals? That last 16 is kind of crazy. Maybe we just want to get rid of that. Because 16 times 8 is good. Let's see how that does. Not great. These sizes are wrong. That's 64 and 56. So it's probably wrong. Okay, so C-Regs has a lot more of these. A wave is a block. Yeah, okay, that's a lot more complicated than just the simple stuff I'm doing then. All right, so this is you see the wave here is do you guys want a quick lesson on how GPUs work so everybody can follow? No, see, we fixed the AMD drivers. That's the difference. Elon tries to fix America. I'll try to fix the AMD drivers. All right, you guys want a quick lesson on how GPUs work? All right, let's go. So here are our docs on the 7900 XTX. We've documented this GPU super well now. That. Oh, is it capable of ECC? I think it might be. Quad garbage. Blah, 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 blah. Whatever. Yeah, there we have one that zooms in on there. Yeah, compute unit. I forget. Okay, so compute unit pair. So it has 96 of these compute unit pairs. This whole thing is called a work group processor. GPUs are what's called SIMT. So maybe you've heard of SIMD. Single instruction, multiple threads is what GPUs are. The problem with SIMD is it becomes really hard to shuffle data around, whereas in GPUs, you don't really have to think about this. You code as though you're coding for one processor, but then this processor runs in what's called a warp. So this warp is what uses the vector GPR. And another thing that I really like about AMD
Again, props to AMD. Yo, who'd have thought that like 2.5 years later, we'd be giving so many props to AMD? So NVIDIA hides all of this from you. NVIDIA doesn't really show you what a GPU is. You can code it in this language called PTX, but then they have a closed source compiler that converts PTX to SAS. RDNA 3 is actual machine code. So this is actual machine code that runs on the GPU. So I'm going to write a syntax highlighter for this. I almost think that like Claude could do it automatically. I don't know why I said Claude. I've never actually used Claude, but I hear it can code or something. So yeah, so this is actually a machine code that runs on the GPU, and it's super well documented, which is another incredible like AMD thing. This document is what got me into AMD originally. The whole instruction set architecture is super well documented, and you can read how these things work. So yeah, maybe. Yeah, so this is the kind of like normal things you're gonna see. So no, don't worry about that actually. It's more complicated than this, but you can basically think of a GPU as a SIMD. Does everyone understand what SIMD is? Let's start there. If you don't understand what SIMD is, go back to freshman year bullshit. But you have to understand what SIMD is in order to understand GPUs, because it is fundamentally it's a SIMD ALU. So the ALU, like you're doing all 32 of the math operations at once. The difference between the SIMD and the SIMT, and I just learned SIMT. I hadn't heard this expression before, but Corsics mentioned it to me. He's a real expert in all these hardware things. Both SIMT and SIMD use broadcasting to send the same instruction to multiple execution units. But so there's two types of registers in RDNA 3. There's scalar registers and there's vector registers. So scalar registers are the same across the entire, so here's the assembly. These S registers are the same across the entire warp. So your warp is 32 wide. These S registers all have the same value, but then these V registers are actually with 32, so you can have 32 different values in them. So yeah, does that explain what GPUs are? I'm sure there's like a YouTube video that like explains this, but we can't use YouTube because it doesn't work. In optimizing GPU performance, how do you balance instructional parallelism with memory latency? So your memory latency is usually not, your cache is going to help, but there's another trick that GPUs use to hide memory latency, and that's warp scheduling. So GPUs have warp schedulers. So that warp, this is a warp that's running. Boom, 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 boom. And then eventually, I've triggered these loads, and eventually I'm going to get to this instruction. And this instruction says you have to wait for the loads to finish. And when you do have to wait for the loads to finish, you can think about this instruction, and I've said this on the stream multiple times, as a context switch instruction. So it allows the GPU to switch contexts. You might be familiar with a context switch on CPUs. I don't like that I look over there. I don't look here. A context switch on CPUs is, why is it more zoomed out now? And it was less zoomed out last time. I have a lot of questions. A context switch on CPUs is used to hide latency from disk and network. A context switch on GPUs is used to hide latency from memory. So that's what this wait count does. And assuming, depending on how many registers you're using. So if you're using a lot of registers and your register file is super full, then you may not be able to schedule multiple warps. But if you are not using lots of registers, then you can schedule lots of warps and it will hide latency with that. This is a 32-bit float map, oh yes. So you see that when we got rid of that last locals, we went down from 22 down to like 14. So that's a lot less good. So now when you understand the wave tile size, the wave is a block of 8 by 4 of the output matrix. So you can understand that you understand what the 8 by 4 is.
So now let's see if we can understand the iteration order of these things. So times tm plus yt. Okay, so that does look like it's the final one is the coarsening, which is kind of the opposite of what I was doing here. So to write this in tinygrad's optimization language, the first thing that we want to apply are two upcasts. So upcasts are this, what they call a thread tile size. Yeah, that's right. Okay, cool. So it's a thread tile size. And then for the other one, they're saying that they have a wave tile size of 8 and 4. What are the output strides of the output matrix? So I think that's going to be, I'm going to do this one first, because I think that we can look at the strides in a minute. I'll show you how to do that. But here we want to do local axis 1 is 8 and axis 0 is 4. And we'll see if we can flip that. All right, so that gets us 9 gigaflops. We can look at the strides here. So this is going to print me the shape trackers here. So this is the output one, and you can see that, yeah, so that's 32. So that one is the, these are the locals. This is the one that's 8. This is the one that's 4, and that's 0 because that's the axis we're reducing across. Cool, so that gets us 9 gigaflops. I'm only executing the code on one GPU here, but we can use them all. You can see right here, well, nothing's actually up now, but we can if we want. Okay. So we're still missing something here because this is 128 on theirs and it's 256 on ours. So something should be upcasting that we're not upcasting, and then we'll get to what we want to do for this 496 in a minute too. By the way, if you want to see what our generated code looks like, just do debug equals 4. And this is what our code looks like. Oh, you know, I might also be able to say devectorize equals 0. This isn't ready yet. It's almost ready. It's so close to ready. And then we don't have to like write all that crap. I gotta make devectorize equals 0 work. That's like my next big tinygrad project. It just makes the code a lot more readable because we don't have to like entirely devectorize the ALUs, which don't really matter. But right now we have to devectorize everything for the load coalescer to work, the load grouper. Okay. So it's probably all right. Block tile size. Number of row or column we read per batch. Duration over BK blocks. Yeah, so like, this is doing a lot of very fancy stuff. We have some ways of doing it, I think. And maybe it's about time we get started really thinking about this, because this is a good example. Like this is a good example of the clear tricks you have to use. It's the same tricks on NVIDIA too. There's nothing special. So, oh, by the way, what this sync threads is. So remember how we talked about how GPUs are warps? Sync threads ensures that all your warps are synchronized. So I don't believe that your individual warps can get out of sync, but remember that our locals are 128, so that is 4 warps. And for the 4 warps, we want we want all 4 works to stay in sync. Because I believe that CREGs is in, oh no, this stuff's in local memory. So this shared stuff's in local memory. We do the reads, we synchronize. If KID is less than reg A, what is that? What's defined here? So we must move that down there. Yeah, we do like a swizzle there. I'm gonna go see if there's any food in the fridge. Yogurt and strawberry. Okay, we found yogurt and strawberries. So I have an idea. Before jumping ahead, let's go through his stuff one at a time. I also found a Squid Game energy drink. And we can decide if we want to drink that or not. Okay, so kernel naive is basically the first thing we do. If we don't apply any ops, we get kernel naive. Let's see if our kernel naive matches his kernel naive. I'll get rid of that beam. Okay, so we're getting 65. Why does he get so many more? Oh, because he has threads still. With a block size of 16 by 16. So that's already way more complicated than what our no thing is, but tinygrad can fully express that. let's just doing 16 by 16 like that. Let's see if our speed matches his. Our speed is faster. Probably because we're doing cool stuff like that. And he's doing the math everywhere. He also has that, which you don't need. All right, so you can see how my code looks pretty similar. We should also modify this to only help with these if it's used. Okay. We launch 496 by 496 threads with a block size of 16 by 16. Okay, LDS tiling. The main issue with our naive kernel is that our inner loop directly accesses global memory. Oh, I like this way of doing it too, because the LDS tiling is actually the thing that tinygrad doesn't do. Everything else we do. But we don't really use local memory much. We use it sometimes, and it is supported. But you'll see how to do it, and it's really cool. I have some start of this somewhere. Inefficient because data memory from global latency has high memory, typically on the order of hundreds of cycles. Since each memory read is followed by minimal computation, the GPU struggles to hide that latency even with a large number of concurrent threads. Moreover, the algorithm reads the same rows and columns from global memory across different threads, leading to redundant memory access. Okay. Yeah. Okay. So we want to load them into a tile. Oh, this is great. Stock's great, because this is the thing we're not doing. So let's write it. Oh, we received a hype chest. I got a frog ponder emote. Share? Choo choo. That's a pretty good emote. Oh, it's limited time only. They're going to take away my frog ponder. Oh well, nothing gold can stay. We're eating yogurt with strawberry. Okay, if we choose tile size of 32 by 32, and BK of 32, all right, well, let's just try to do that with the 16 by 16 first. So I have some stuff that like vaguely supports this, and I played with this once, but I don't know. So okay, let's work on what the AST is. We can also do this on the Mac. We don't have to do this here. It's probably nicer on the Mac to do this. And I'm going to kind of consider this done. I'm going to copy this. Matmul. This shit matters. Do that. Do that. Wow. Okay, that prints a lot. Okay, so we can commit that later. Oh, it's also it's boring if we don't do that. 'Cause, 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 this on the top of the file. Great. So now we have an example. We know what's theoretically possible. We're checking the output. I love to know what's theoretically possible. It's kind of a lot. Let's just check if it starts with text. We don't want someone to like accidentally name a variable dot text and then, you know, done. We're going to disable compiler cache. Cool. All right, that should be doable to commit. Wait, where's my, oh, I have to force add that. Do you have a license? MIT. All right, cool. When you take in someone's code, always consider the license. It's great to have like a simple example like this because we can just iterate on tinygrad until we hit this. There's really just one trick that it's using, and we have to, you know, use that trick. It's similar to what we're doing for the tensor cores. We already kind of do this for tensor cores. We'll get to how that works in a minute. Like half of the reason tensor cores are good is because of this trick. But we can't apply this trick generically. We can only apply it for tensor cores. So let's apply the trick generically. We'll work on that same branch here. And we'll make it work on non-AMD. We want to work on the same branch? Yeah, I think we do. I tell you about the Squid Game energy drink. Should we get the Squid Game energy drink? Let's go here. We're on 32, new window, tinygrad. We already have it over here. let's get rid of that line. We only do this if device.default. There, that can be printed all the time. That shit should go down there. How are we doing with so let's beam search. Can I do beam? How do I do beam? Let beam search work. A lot of complexity. All right, no beam search it. Let's apply those odds. Looks pretty good. All right, that's actually not too bad. So remember, we're not applying any tensor cores here, and we're getting 2 gigaflops. If we want to see this with tensor cores, we can just do simple matmul. The tensor cores on Mac actually work at FP32, which is cool. So we got like 11 teraflops. And we can throw a beam on there and see if we can get it faster. The beam on Mac is fast now too. UUVN figured out how to access the compiler from anywhere. So good bounties paid out for that. Let's see how fast we can get it to be. Look, it's already faster. Look at that, 11. 11 versus, there you go. Yeah, meh. Get 11 teraflops. But that's using the tensor cores. Now, what if we don't use the tensor cores? I'm sorry, you just have to know these magical incantations. Yep, that was people doxing all the Doge people. So a Google alert for comma.ai. You know, we got Doge people. We got comma.aiers in the Doge. Yeah, props to Elon for trying. He's gonna like sort of win too. It's gonna be so interesting. Do I look like a Hong Konger? I was trying to buy a jacket that made me look as like Hong Kong as possible. If you don't have people with names like Big Balls, don't worry. Doge has got the big balls. Yeah, I wouldn't bet against him. I wouldn't bet against him. We got to fix immigration, though. Immigration's the main thing that's going to save America. And sell your GPUs to the world. Oh my God. Look very Hong Kong, right? Thank you. Thank you. That's what I was going for. All right, so if we don't use tensor cores, we only get 6 gigaflops. So let's get more gigaflops. All right, so we only get 2 if we do that, but all right, so we have like transforms of the AST here. It's get optimized AST. So this thing is what's capable of adding the tensor cores. We're gonna need to stick define local and stores and stuff in. But yeah, I mean, this has been something that I've been thinking about for a long time. I think I even tried it once, but I never went far enough with it. We'll see if I have the motivation to go far enough with it today. You know what I think we need? You know what I think we need for the motivation to go far enough? A Squid Games energy drink. Let's go get one.
crash out here. So. How nasty is this gonna taste? Let's take a look at it. Oh, how NVIDIA will be nationalized? Yeah, I mean, do you not think the AI Diffusion Act is kind of like a start of that? That's like kind of exactly what it is, right? Well, like, if the U.S. doesn't nationalize things by, maybe like the socialist El Governmente Socialismo de Argentina might. The U.S. nationalizes things by, let's start by banning the export of their product. The AI Diffusion Act is, in many ways, the nationalization of NVIDIA, or an attempt at that. Is it not? Yeah, it's nationalized all but a name, exactly. So if you tell a company, oh, you can only sell to our market, right? Like, no, look, nationalization is obviously on a spectrum. It's not extremely nationalized, all right? But yeah. So, was I off? Was I wrong, guys? All right. The Squid Game energy drink. The Triangle edition. I love the triangles. Triangles are my favorite. It's got lots of Korean writing on it. So you know it's good because it's got Korean writing. Oh, yeah. Korean writing good? Korea falling apart? Is that true or not true? Is that disinformation? Let's just say I wouldn't live in Korea right now. I spent a lot of time there. And there's things that are wonderful about it, but there's things that are also trouble. Yeah. The Squid Game energy drink. Is it good? Is it good? Should we drink the Squid Game energy drink? Do we need a poll for this? Marry into the Samsung family. Yeah. Should we drink the energy drink? What are we doing, boys? About the pros and cons of Hong Kong. Let's crack open the Squid Game energy drink. Talk for 2 minutes about pros and cons of Hong Kong. I don't want a 5090D. Bet everything I want over SSH. No, I'm not joking. It's a Squid Game energy drink. You thought it was a joke? This looks like a joke to you? This is real shit. Every energy drink tastes bad at the start. That's a good idea. I still remember when I was 17 and had my first Red Bull. You want to talk about a gateway drug? You want to talk about what got me into drugs? It was energy drinks. But now I'm not into drugs anymore because I'm in my 30s. And if you're still into drugs when you're in your 30s, there's something wrong with you. Drugs, there's a South Park line that I love, and there's a time and a place for drugs, and it's called college. And shit, I did a lot of drugs in college. And then I grew up and became an adult who still sometimes drinks Squid Game energy drinks, which who knows what kind of weird Korean drugs are in here, but it's legal in Hong Kong, so it can't be too crazy. Pros and cons of Hong Kong. The only con is that there aren't more good software engineers here. Like, I wish there was a group of... every single software engineer living in San Francisco, you will be so much happier if you pack up your shit and move here. You will be so much happier. So many little stresses of everyday life are just gone. This is a efficient, beautiful country. Um, and it's beautiful on many levels. There's nature here. I go hiking a lot. I love hiking. There's look out at Victoria Harbor and like see the buildings. So there's the techno beauty and there's the natural beauty. Again, I told you my experience getting my mole lasered off. Wow, that was good. When I got this haircut, like it was like a massage haircut. It was wonderful. It's just life's just really good. I don't know. Yeah, I've been to Repulse Bay. Yeah. I've chilled on that beach. Um, Thank you. I stopped getting. I'm not saying if like you smoke a joint or have a beer or two on the weekends. That's not what I'm talking about. I'm talking about the 35-year-olds who think taking ayahuasca is a good idea. What the hell is wrong with you? And I'm not talking. Look, there's kind of like the hipster artist type who takes drugs like that. Good on them, right? That's not who I'm talking about here. I'm talking about the 35-year-old software engineer who decides they are going to find themselves in South America and goes on an ayahuasca journey. You are who I'm talking about. Don't do drugs. What's wrong with that? I haven't taken kratom since I was like 24. Ayahuasca is how you quit object-oriented programming. No, what happens with these people is they think they find some magical thing, but really they don't find shit. And I like the Twitter, though you got one-shotted by the Aya. Yeah. Dude, it's just for fun. You never worked 9 to 5, George Hotz? You cannot relate? Wow, I can't believe you people are defending drugs. Yeah, the deeper meaning. You think you found meaning in a fucking South American jungle? That's some dumbass shit. Oh yeah, I took some shaman drink, man. Yeah, if that shit was so meaningful and so advanced, where the hell are those societies? Right? How much energy they generate? How much steel they producing? Yeah, that's what I'm saying. No, I'm gonna circle jerk in my head, man. Oh, wait, I never worked 9 to 5? Dude, what are you talking about? No, I was in person at Twitter. I worked a lot more than 9 to 5. That was my entire life. You can look at my GitHub. No, I mean, Elon, I work about 60 hours a week. Elon's guys work 80. And like, no joke. They are Elon's top guys are a level. I could, if I could work 80, I'd work 80. I just kind of can't. Like, my mind just doesn't work that many hours. I do work 60 hours a week, and don't think I don't have a 9 to 5. I go to a co-working space every weekday here, and I get there around 9 o'clock, and I leave around 7, and I do that every day. On the weekends, I take one day off on the weekend, and then I usually do like half work one day, like this kind of shit. Yesterday I didn't work. I was so tired yesterday. I slept most of yesterday. At Twitter, 5 weeks. Yeah, there's been a lot said about that. I don't know. It wasn't my calling. Working at a social network is not my calling. I quit and I went to tinygrad. I started working on this. I'm working on this company now for like 2 years. We got a good crew of people working on it. We have our own AMD driver. We did it. Like, that was the original goal of you see on my
lights up. I got an OLED monitor. Another like. By the way, I bought this at like a store here. Have you ever gone to like a store, like in America, and like bought a monitor? I don't think you like. Maybe like some of them are okay, like Micro Center and Fry's. But no, the Amazon like doesn't work here, so you have to buy things locally. But like, it's not a big deal. It's all functional, which is actually like kind of cool. If you're the kind of person who's into like, I can go to my local shop and talk to my local guy. You know, we got people with 110, 115 IQs on the corner selling fruit, and they're good at it. So yeah, no, I mean, our short-term goal is to get AMD on MLPerf using the tinygrad framework. We've succeeded at doing that. We're going to write our own software. So we have not replaced LLVM yet. The last piece that we haven't replaced is LLVM. I mean, LLVM is also, it's not like as far as software goes, I don't like, it's not like the AMD driver, which is chock full of bugs and like, or AMD's other stuff, which is like copy of video garbage. Like LLVM is the greatest optimizing compiler framework in the world. You know, maintained by Apple, started by Chris Latner. Like this is not a bad piece of code to depend on. So I'm okay with. Wow, languages. LLVM is 40% written in LLVM. This is not a bad piece of code to depend on, and it is AMD stuff that they committed to it. But you know, it's just it needs to be removed eventually, and like you'll see why, or at least fixed. Maybe it can be fixed. I don't know that much about LLVM internals, but when he gets to 5 here, yeah. Before we go into the next observation, I need to be able to directly compile the ISA. So we're skipping ahead. We're gonna go back. We're drinking the energy drink. We're doing this. We're doing this. There's these like dual issue ALU instructions, but they're very picky about which banks they can pull the registers from. So like, yeah, look at this. It's funny, like this almost looks like the same, like they talk about the bubble problem that DeepSeek solved. It almost looks like that. So many of these problems in AI infrastructure are just the same problem repeated over and over again at different scales. And my dream is with tinygrad, we can like unify all of this. But it's a long journey. Yeah, if you want like the big market, you can go to Wanchai Computer Center. I've been to Wanchai Computer Center, with the Golden Computer Center. It's up there in like Mangkok, Sham Shui Po area. I can't pronounce any of these. Yeah, it's a little sad that like everyone here speaks Cantonese and not Mandarin, and learning Mandarin is hard enough. Cantonese has like 7 tones or 9 tones. It's crazy complex to even hear what people are saying in Cantonese is really hard. Like Mandarin, I'm to the point where I can hear what people are saying. Like if I like listen, I know what people are. You know, my vocabulary is not that great, but like at least I know the sounds. Cantonese is so much harder. I went to Magic on Friday night, and it's like great. You know, you take the public transportation there. I went out for a beer and some like string beans with pork afterward. Every software engineer living in San Francisco, if you move to Hong Kong, your life will get better. Does that answer your question? So we're going to have to define locals. We're going to have to transform the AST. So we can print the AST right here. I should print it before it goes to the kernel. I probably want to... No, see, we have to do that afterward. So you see, like, we can do stuff here like print k dot get optimized AST, and we can see what like that looks like, and you can see that these shapes here are now these. Why is there a view there? Why is there a view there? So we might have to put it in there. Let's think about what we actually want to write. And notice how like the modified AST tells you like the number of local dims and stuff. So that's these local dims. Upcasted is 0. That's a reduced dim. So I've written this before. It's kind of what I've already written in here for TC. This one needs to be cleaned up and refactored. It's like before the mall, we need to replace those loads with local loads. Let's just add a function in here called there's an optional, should I? Yes, that's in 2 program. It's all pretty deep. Do this with a graph rewrite, probably. We just want these loads. Yeah. Show you how to use the rewrite infrastructure from tinygrad. now. No op is no op. That's good. This is similar to the kind of rules that you see in LLVM and MLIR. So we have a load, just an index. Shouldn't really be a lambda. This is being called with the loads. Turn native loading pad object. Why not? What does that mean? Okay, so you see how we're getting both the loads here? So this is a good place to do transformations on them. Let's add in a store. I've never tested any of these code paths before. So like this is a testament to like how well tinygrad stuff works, and you might see me just get frustrated and be like, this shit doesn't work. Because we're not ready for it yet. Okay. First we want to define a local. So let's define a local. Forget exactly what the syntax is for this. Do I have a helper? I don't. I use this in kernel though, don't I? Yeah, here. Let's just take that from the, okay, so we have x.dtype.pointer, local size is 256, right? 16 times 16. And for this, we're going to want to call it x dot, let's just do x.source1.arg. All right, so we want to store. Store has dtype void. Our sources are local and x. That's probably right. If x dot source zero dot op is ops dot define local, we want to return none. Okay, let's continue on here. Load, we want to load from local. We're going to need a shape tracker. Actually, we're going to need a shape tracker on both of these. Store has, yeah, we need a view. This is deep tinygrad. Hopefully it's like kind of understandable. Like I'm not doing anything crazy here. Shape tracker from shape. So we want the shape to be 1, 1, 16, 16, 1. And then actually we'll just call that local shape. And then I believe that shape tracker has a method called size. Yeah, we'll do that. So just do local shape.size. That's right. Is it a method or a property? It's property. Shouldn't that return a shape tracker? Why didn't that light up? Why didn't that know that's a shape check? Oh. Pass the tuple in there. Okay, now it knows it's a size. I love syntax highlighters. Okay, so that's actually not right. We want to also pass in local shape.toUp. Is a method on a shape tracker called toUp? Yeah, it's a view. Okay, good, that works. Okay, we want to load from local shape UUp. We want this load to depend on that store. And that should be fine to return. I'll show you guys what the code actually did in a minute. So that's define local, that's define local. Why does that loop forever? I should not do that. Or we do have to give this a type. Why does that loop forever? Still loops forever. Interesting. Oh, because it's the other load. Yeah, okay. You see why it's looping? It's just adding more and more of that shit. There's not really a way to check the children. Okay, that's something. Did it work? It looks like it didn't do anything at all. Why didn't that transform now? So that'll stop it from hitting twice. But now we get nothing? Okay. Leet debugging. So that's returning something. It's just not printing it. Oh. Oh, wait, this is not right. That's just not right. Okay, whatever. Whatever, we'll print it here. No, that'll show me the modified AST. Okay, good, that's something. It works, it's just slow. I think the code might even be right. Okay. Yeah. All right. It's kind of wrong. Yeah, okay, this gets into what we want to do. We basically want the local threads to copy the chunk of the matrix, then to synchronize, then to do it. But we are now copying this into local. It's just that each thing is copying it into local. And we're reading from local. Yeah, which is all fine, but it's just not really right. Just think about what we did here. So this stuff is like the right sort of way to do this. The way it's done in TC mol sum instead of WMMA. Okay. Emulate the warp addressing with loads. I already like wrote all of this, which is ridiculous. I could have just copied it from here, but I didn't do that. All right, it's basically the same thing. Yeah, that's exactly the same thing. Okay, that's just the code that I just wrote. Wow. But yet, how come? What if I do TC equals 3? Does it still work? TC equals 3 is clearly something else. Let's think about why it's different. Oh, get TC swizzle ST. Ah, it's doing the swizzle. We gotta do the swizzle. Oh. Yeah, so we actually want to load and store differently. That's the whole trick to this. Guys, it's a victim, okay? It's a victim. It was a victim of GPU error recovery, and it's entitled to compensation. Okay, it's a victim. Jeez, okay, don't do that. Oh, it's because I ignored the beam cache. Whatever. No, you can't make fun of victims. Victims have had it really hard. Really hard. Let's read that and think about what it's doing. Now let's work this out. Okay. So this is upcasting the tile size? Yeah, something like that. I see. Okay, so well, that's not right. We should have more shape trackers. It's clearly not being printed from the whatever. It's not a big deal. We can just read it here. Okay, so X7 here is the yeah. So I believe that each of these is only using one of global/locals. And that's what we need to do. We need to move the useless ones into that somehow. But I don't exactly know how to do that. So let's try here with, let's throw 16 upcast on axis 2. Oh, that's gonna whine. Because I didn't. Yeah, not axis 2, actually, sorry. Unroll. Unroll! Yeah, so I think I need just one more 1 in there. Fix this later. Zero not equal to 1 with 2 sources. No, first let's make sure that if we don't do the AST transform, it's fine. Yeah, it's fine. Now, you see what we're doing here? We're upcasting there. Or unrolling there. So that's going to read the group, and that's effectively what BK is. No, here is fine, but let's put this transform back in. Okay. 0 is not equal to 1 with 2 sources. Now let's read that. It's unexercised paths. We don't know if it's going to work. Oh, this crap. Yeah, it's because the loads have that extra store there. But that's not actually a gate. Should be removed by then, though. Let's take a look at Viz. What? Should I hit the firewall or something? What? Preparing profile? This is crap. This is starting. Why is it not printing the URL? What is the URL of Viz? Why isn't it running? All right, again, let's disable that transform and see if Viz works okay. Do we break Viz somehow? Viz is fine. Why was that crashing? So you guys can see Viz. You can see Viz? You can see what's going on. But something breaks Viz. If we do that, it's not the pro. No, it breaks. So we can disable the profile. Actually, I haven't tried the profiler. Does profiler work? It's just hella slow. No one has time for this. Is it even loading? Oh, yeah, okay, it kind of works. We gotta make that faster.
but we have all that data. It's going to be so nice when this is integrated into Viz. Like right now we have to like load Profeto probably from the internet. And right now we're doing the same kernel over and again, so the profile's pretty boring, but check that out. Like, and you just get that for free in tinygrad. Think of how much effort that is to set up in other frameworks. Oh, well, this is going to take 2 days. But it's not the profiler. That's not even what's breaking it.
Something's breaking Viz.
Oh, it was just hella slow.
Causal, why is it slow? Alright, so here's a store. Oh. What? No, that's not even right. Okay, put that back. That's normal enough that it should work. But it doesn't for some reason. Why does that take 5 seconds? Okay, it works, just something's broken, that takes 5 seconds. Okay, whatever. The store only has 2 arguments. How does this have a successful... This is what's failing? There's 2 arguments to the sync. Oh, it's these stores that have lots of arguments, okay. What? Oh. Yeah, it probably shouldn't be rewritten as a sync. Oh, because it's trying to fold that. But that should actually be right. Those stores look okay. 0 not equal to 1 with 2 sources. What? Who wrote these junky error messages? I know it was me. Arg not in offset root sources. What? Does anyone understand this? All this code needs to go. This is the code I was complaining about before about the devectorizer, whatever. Just don't rewrite it then. Okay. It gives me something. It's just unfortunately wrong. Wrong. Truly think about how TC3 does it. Forget beam. Because TC3 is this, but working. Sort of. What is all that? Just pre-computing all of that? Wow. Oh, well, it's doing something right. So what's wrong there? Oh, because it should have dimension 16. It just should have stride 0. Yeah, we need a lot of like stuff to make this easier. Yeah, we have to permute that probably. So yeah, who wants to listen to copyrighted music? You ever just get that urge to listen to copyrighted music? So the store is fine. It's the load that's wrong. And why are those in a leave? They totally shouldn't. Oh, I see. So this is the here. Why is it writing to the same place over and over again? That's just not right. Yeah, that's totally not right. Yeah, okay. These shapes aren't right. We have to say here x str str called on view, but what else am I supposed to call it on? Oh, get host by adder because of tail scale? Because of socket? Because of server name? I hate all these. Oh, I hate computers, man. It's disgusting. That's why it was being slow. Causal, it's not your fault. It's not your fault that whoever wrote Mac OS doesn't. Really? Get host by adder? Can someone figure out how to disable this? Can someone figure out how to disable this and do a pull request? Almost clicked exit on OBS. I didn't mean to. Alright. So yeah. Above palm trees. You guys know the song Goodbye Sky Harbor? Beautiful song. We are smaller than smaller, but I still see. Oh, this is the copyrighted music. No, actually, I want to listen to Taylor Swift, which is super bad because that's super copyrighted. You can't just like listen to Taylor Swift, man. You gotta get Taylor's permission first. I think that's right. Okay, that's wrong, but and yeah, that's just because I'm pretty sure those stores are right now. We're gonna probably have to make the load in the store different. Oh, okay, I gotta fix all that devectorized garbage. There's so much to do, guys. There's so much to do. Okay, look, that stuff's all right now. But this is wrong. Okay, now we expand that. Oh, one of them's probably permuted wrong. Yeah, one of them's permuted wrong. Well, if you want the naive permutation. Okay, let's copy it from kernel where I actually did this correctly. So I get the shape tracker where? What if we listen to a cover of Goodbye Sky Harbor? Is that still copyrighted music? That can't be copyrighted music. What if I listen to Goodbye Sky Harbor and you guys don't get to? Man, who's feeling this Squid Game energy drink, you know? Take back what I said about drugs. How did anyone ever make any of this work? Can't be right. That's not the local size. Those should be 0. Oh. No, do they have stride 0 or something? That's just not right. How does this work? Because there's no way that... How does this work?
I think it doesn't work. Great. Copy wrong code, why don't you? Guess this is wrong. Who broke this? This was broken in one of the tensor core refactors. Whatever. It's not a real feature. We have bad testing for it. But this is wrong. I'll leave the kernel crap, whatever. It doesn't hurt anybody. We have to think about what we want to do. A few things. This stream needs music, and I need some speakers because I don't have any speakers in this room. Like at work, I have noise canceling headphones, and here I have AirPods. But we need some bumping speakers, you know? Bump, 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 bump. Okay. Let's think through the shapes and get them right. It's amazing that any of this shit works. I should just rip all this out. It doesn't work. Like use tensor cores 3 is just broken. What is use tensor cores 2? 3 is broken. Emulate the warp addressing with locals. Like this isn't right. All right, let's think about what we want to write. Let's think it through. We have something that's a tile size by the tile size. And then okay, that's probably right then. No, okay, we want the load. I guess we want to separate the load and the store. Okay, we want the store to just be here. But the load doesn't have to be there because the locals are different. Okay. All right, we're making progress. We're making progress. Okay, we want the store to just always be the local shape, which is 16, 16, 1. Let's do that. Wait, what? Huh? No, the problem is we want to change this load. I just got rid of the load? How's this even right? What? Yeah, okay, I'm just storing from that load. Okay, that's not what we want. All right, there's actually a load, a store, and a load. Okay? Is everyone with me? Okay, so that is being loaded there. But we don't want it to be loaded like that. Okay, I got this now. I got this. I got this. I know what's up. I know what's up. Let's go. We have a shape tracker here. We'll save this as strides because that's what's going to matter here. So if we just make this the local ST on all of them. Yeah, that's good. Actually, we should do real size here. We should just do size. Great. But now what we're going to want to do is we're going to want to swizzle. All right, everyone know how to swizzle? We're going to want to stick that in that hole. If stride sub 2 is 0, we want to both transform the input okay, local ST equals local ST dot permute. We want to swap 0, 1, 2, 3, 4, 5. Do I have a convenient swap method? I should. 0, 1, 2, 3, 4, 5. I'm going to do this to the input ST as well. Because that stride 2 has 0, we want to stick 5 there, and it's like that. And then for this one, that goes there, that goes there, and that goes there. Okay, is that right? No, and then for the load, we don't actually want to change this. We'll call that load ST, or sorry, store ST. Oh, and then we actually want to Premier takes 2 positional arguments, 7 we're given. Okay, fine, be a tuple. We get some bumping speakers. I'm going to listen to copyrighted music. The small joys in life. No. Oh, because I didn't actually change the load. We have to update the load. X dot replace. Global load equals X dot replace source. X dot source wall 0, which is the buffer, and then input st dot to uop. Then instead of that, those can stay X, that's fine. But the one that has to change is this one. Cannot access variable store st not associated with a value. What? How is none of them that? Oh, because of this. I don't need context anymore. I don't know. I'm just leaving this, do that, fine, whatever, go. Okay, that looks more like some code. Except that's still wrong. We're still jogging on that. We don't want to. We actually want to do the opposite. We did this wrong. We wanted to put the 0 stride there, which it should be now. Hang on. So we're doing that store to 14. Oh, just the global. Okay. No, that's not what we want. That's 0. Okay, that's right.
that should be 0, but then this one shouldn't. The store shouldn't be that. So maybe we don't actually want store st, maybe just put local st there. All right, we have one copy happening. Now this is wrong, right? The one copy is correct. So this basically, I don't know why those can't be on the same line. Whatever. We should use a fast instruction for that anyway, but so this is now this. See that? See how these two things are the same thing? That's now that, except we do all the indexing outside. All right, so notice how they're indexed the same. That's just ALU3, which is LIDX plus LIDX0 shift 4, right? And then that is that indexing there. Now these are incorrect. This other load is incorrect. And that's incorrect because this is the one that should have been, this should be load st. Store can be that, but load st needs to be that, so it expands. Okay. Is that what I expect to see? Is it just missing a thread group barrier? No, this thread group barrier should be right. Oh, they do sync threads at the end. There's a reason you have to do sync threads at the end. Yeah, it's missing a sync threads, I think otherwise it's correct. So this is unrolled. We don't actually have to unroll there. We can just split that. Do I have a method for that? I'm not sure I have a method for that though. I don't have a method for that. Whatever, it's fine to unroll it. It doesn't hurt anybody. But that's basically just that. That's that sum. So I think we're just missing a thread group barrier at the end. And this is an extra thread group barrier. We don't need that one. Because the problem, what's happening here, is that these loads, some of these stores are happening before these loads. And it's getting like the next one looped around. Does that make sense? Let's fix this hostname garbage. Can't really get it. Can I skip this somehow? Da, 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 da. Da, 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 da. Override server bind to store the server name? Why does that even have to happen? Fix it all. So what is that on? Here, I create the HTTP server. Bind and activate equals true. What? Oh, is it just because of this? I can do that. Okay, that's fast, whatever. No, it didn't work. isn't even a real thing. Why is it doing that? Is that all an HTTP server is? Yeah, okay, what if I just do that? There we go. Now I get a socket server. Socket server. Okay, you happy? You happy? You just lost your HTTP because you're a little bitch. Yeah. Oh, now it works. Oh, who's a little bitch now? Yeah, you thought you got to be an HTTP server, but now you don't get to be an HTTP server because you suck. But I have to override it for that. I have to override it for that? Yeah, that's right. That's right. You're a little bitch, and that's why you don't get to be an HTTP server anymore. There we go. Yeah. There we go. Oh, look how fast it loads now. Oh, look at that. Look at that. Remember when it was taking 5 seconds? Now it doesn't take 5 seconds anymore. Yeah, Squid Game energy drink. Yeah. Alright, so now I can look at all these great high quality shits. Okay, why doesn't this work? Oh, I think it's just because of the synchronization. We should just like test that first. It's kind of annoying to test, but so if there's a barrier inside a loop, we have to add another barrier to the end loop. How do I express that logic? Where do I inject end loops? Is that like C style or something? That's a linearizer. Alright, let's stick this somewhere. So we run it through this linearizer thing, which makes it a line. Oh, does anyone want to listen to copyrighted music? You guys remember the horse from over the garden wall? You know, surely Fred doesn't want to partake in your schemes. And the horse is like, I want to steal. Horse knows what's up. So if we merge something into an end range that has a barrier, we have to insert a barrier before the end range. So what's that in? Block merge. Yeah. Okay, if it's a block end, is it a block end? Yeah, it's a block end. See if we were done with placement. No, but okay, yeah, we're just doing this. Yeah, let's check the sources. Okay, if the source is a block, okay. If x.op is ops.block end, and any y.op is ops.barrier for y in u.source, to append.extend, but that should be the other way around.
Oh, I put it at the end there. Okay, that's fine. Probably okay. No, that kind of needs to go at the end. That's not really where that belongs. It's actually more like when I turn the block end into a non-block end. So is that in block finalize? No, it's not block finalize. It's not in make basic blocks either. It's definitely in block merge. So when do I convert it into not a block end? It's here, okay. Yay, this is what we want though. To be before the, yeah, this is where I insert the define ACC, so this is the right place to do it. Yeah, we gotta add late. What are late ops? Oh. Okay. And extra.end in my source. Wow, this stuff's hard to read. So it's never going to be an early ops, so I can just stick that in there, but you probably have to stick it before the end range. So it actually might be. Okay, that's failing a type verify. Yeah, we have to stick it before the end range though. So maybe. Yeah, no, so that's actually got to go before the end range. That should be right. Okay, so that is a correct barrier. However, it's failing the verification, which is okay. We just need to allow that. Yeah, all barriers must come after stores, but that isn't necessarily true. Barriers also happen at the end. Oops. Sweet. I think the code works now. see any error anymore. Great. Beautiful. All right, you see how we had to stick that barrier in there? That's actually an extra barrier, and we should be able to combine those barriers. Barrier. Great barrier. Yeah. Does that make sense to people? How that's LDS? Oh, you know what? We can also put the barrier at the top. We don't have to put it at the end. Might be an easier place to put it. Let's just see what makes more sense in the code. We have to add another barrier. Requires it to be before the range. So early ops parent block.org list. Okay. Let's stick it in the front of the loops. Yeah, it's correct as well. And let's see what they did. What's a natural way to write that? They put it at the end. Put it at the end or the beginning. It doesn't matter. I feel like it's more readable at the beginning. I feel like that code's more readable. Yeah, that makes sense. All right, should we get rid of that barrier? If you don't need it. Let's take a look in Viz with our new fixed HTTP server. Man, I'm feeling this Squid Game energy drink. Oh, I love branded content. Don't you love branded content? And copyrighted music? Oh, Boner pulls down for copyrighted music. Okay, so remember that, whoa. This is like, you don't get how unbelievable this tech is. So this is, remember that thing that we wrote in AMD mapmol.py? So you can see AMD mapmol.py there, and that's what the transformative load looks like. Oh, come on, that's nice. That's nice, right? Alright, so let's see. Here's the barriers. How do we tell it that it's the same barrier? I actually don't think we can. Maybe in the linearizer we can. We can write that in linearizer if you wanna. You wanna write that in linearizer? Just remove that second barrier. So because there's only loads here, you need basically barriers separating load. Thank you. You need barriers basically separating loads and stores. And because it's all loads here, you don't need this barrier. Should we write logic to take it out? Fine. Write stupid barrier logic. Okay. No, that's really hard to do, actually. This is not easy. The simple thing does not work here. You know, there's lots of edge cases for that. I don't care. That other barrier can't be that slow, can it? All right. So this is LDS. This is working LDS. Probably shouldn't hard code 16s. He has a name for it. 16's a lot. Okay, this is we're doing LDS tiling. Think it's gonna run and oh yeah, no more HTTP server because HTTP servers are bitch. Wow, the Squid Game energy should fuck me up. Yeah, we'll fix Automon. All right, does everyone understand what we did? Does everyone understand? Does anyone not understand? Are we all on the same page? We don't want any children left behind, okay? Oh, perhaps something typing's callable? I did mean typing's callable, actually. Thank you. I don't know why I can't use built-in callable, but okay, fine. I'll use typing's callable. Are you happy? Incompatible type and assignment. Expression has type int. Don't use an int. Wow, is that... Does Python not type check? Seems to make sense in testing environment. This is the code that's the Python. That's the standard library for Python, guys. I love Python and I'll always love Python, but you guys need to get your standard library to type check. That's just crazy. No, come back. That's cool though. It's just a TCP server. TCP. Recap? Not commonly used. No. That's not what I'm saying. I'm saying the literal standard library doesn't type check. Like someone should submit a. I should submit a pull request. Can someone right now go submit a pull request to the Python standard library and change that 1 to true? I don't know. I've never submitted code to Python before. I should look into how to do it. Should give back. Just with little stuff. Like getting their standard library to type check. And adding that to CI. I do love how much of Python's standard library is written in Python though. I love Python. Nothing ever is gonna bring me down, you know? I love Python. Alright. We added LDS tiling, that's great. Let's see if that runs on AMD. I think it will. I don't see why it wouldn't. Oh, I do have some thing there about if, whatever. Yeah, we're running the fast one. We're running the fast one because the default device is AMD. Okay. go. Now we're running the slow one. And that's basically the same code you're going to find on the, I mean, you see that like it renders the barrier shit differently, but is that how he does the? He has this auto magic called sync threads. I think that's like some other shit. Release work group, barrier, acquire work group. I don't know. Maybe you only need barrier. Maybe you need them all. But does everyone understand how this is basically the same code? That's junk. This and that is just basically that loop unrolled. So we are through step 1. We'll just let's add ln here. It says 16, we'll say ln. I'm not sure you can get n0. What? I told you to be 32. Oh, I changed it on the wrong computer. Hate when I do that. All right, X. X. Copyrighted music. You're gonna want to be like, that's too many threads. I don't have that many threads. Ah! What's type Python script and who's Anders Hedgeberg? You wrote Turbo Pascal. Interesting. He's working on Python right now? Microsoft really has the best people for this. If I Google type Python script, this is a real thing? No, it's not a real thing. You're trolling. It keeps trolling. Keeps trolling. Oh, well, yeah, it's a joke. I thought it was real, man. I was excited. If you can add types to JavaScript, you can add types. Python has types. They're okay. Python's type system is okay. Yeah, it's not great. It could be a lot better. Every time I've tried to do like typed tensors, they don't really like work. I don't know. What language does types well? I mean, the C++ has good types for all of its other problems. The Rust's type system is fine. TypeScript is okay. TypeScript, like again, you guys know when I troll Java. You guys know about JavaScript and adding the numbers, right? Like their integer is not a real integer; it's a float. And there's apparently some keyword to fix it, but I'm sure there's 6 different keywords to fix it, and they only work in one kind of browser. But don't worry, you can use Babel, and everyone's going to use this React framework anyway. So why not just, it's what a trash ecosystem. Why is this why is this one not here? Go there. No, don't do that. I need to go there. Also, don't use so many registers. You're using a lot of registers. Stop using all the registers. I really don't want that to be an upcast. How do I just make that not an upcast? Yeah, big hacks. That's just gonna work. Nope, still an upcast. Oh, I know what to do. So what if I... What? Huh? No, you can't just do that. Yeah, okay, no, you really just can't do that. Never mind. Whatever. Okay, it's unrolled. It doesn't have to be unrolled. But it's the same thing. I'm writing basically the same thing, and the compiler should be smart enough to fix it if it's not the same thing. Okay. Great. Our occupancy is pretty good, but our VLU utilization is crappy. Okay, we want to do register tiling. Each thread now outputs a 4x4 block. Since a wave consists of 32 threads, we organize them into an 8x4 block. Each thread will be responsible for producing a small tile in the output matrix. That's a thread tile. That's a wave. That's a wave tile. We're using a 2x4. Two by four. Each wave. Essentially, it means each thread I'll be able to compute an 8x8 output tile. Right, this is where this stuff's starting to lose me. Let's follow it through. Very simple. So register tiling gets you huge gains. And this is probably kind of where tinygrad stops right now. But okay, load the tile to LDS. That's great. We want... Yeah, so, okay, I mean, it just seems like that's just an upcast. So we should just be able to do that, right? Let's just do that and see what happens. This is gonna whine about a lot of stuff, but we'll deal with that later. So this is doing the locals before the upcast, but this one's doing the upcast. Like, there's a question of like how you want to do this, right? Do you want to do the upcast or do you want to do the locals? So I'm surprised that the fastest ones do the locals first, but whatever. So what that 4x4 thread is just this upcast. It's an operator called upcast in tinygrad. Sorry, we've done LDS tiling. Now let's move on and do register tiling. Register tiling is already a supported operation in tinygrad. It's a very easy one to think about, so we can just do that. Okay. Yeah, it's gonna bitch. Of course, that's gonna bitch. Okay. What's our size now? Okay, there we have this. Let's just print. It's a function or property? Okay. So where do we inject the new args? Those those two still go there. That one still goes there, but then we have two more. So we'll start with 0, 1, 2, 3, 4, 5. First, let's just refactor this. Zero, one, 0, 1, 2, 3, 4, 5, 6, 7. And we want to switch the places of 7 and 2. And for this one, we want to switch the places of 7 and 3. Okay, it has length 6, but oh no, sorry, I counted wrong. What? Oh, this one just needs 2 more. 1, 2, 3, 4, 5, 6, 7, 8. We'll stay there if I go. Okay, something, except it's wrong. Let's figure out what's wrong. If we're upcasting those to 4, oh, then I think we're going to have to increase that as well. I mean, those 4s are definitely real. Wait, what? Number of rows or columns we read per batch. This is a lot more complicated now. I think this might be fixable by just putting 4s there. Okay, that gives the right answer. Let's look at what it's doing. Why is there so much crap? Oh. Right, that doesn't work. And we are computing that now. These are the... Oh, that shouldn't be happening. Why would we want to store the same thing multiple times? So that's just what we have to set the strides to 0 for. That's not actually the local shape. You see what I mean? Like it's just got to be stride 0 there. Because look at what this is doing. This is copying the thing into local memory that many times. But this is going to work out to be the same thing, right? Because it's 128 times 8. Even though I think we did other stuff wrong too, but whatever. Yeah, we can definitely get rid of a lot of this by changing local ST, which we use there and there, yeah. So that is the right shape, but we want it to be a different view depending on, so I'm gonna have to create this till later. strides. I get the real strides somewhere, don't I? Yeah, here. So it's like kind of right, but not really. I think if I just zero out the first two. Subtotal. Is that right? Compile and count an internal error. Right, that's great. Yeah, well, because that one's fucked. Look at that large number. Not what we want. We could just like manually write the strides. It's not that big a deal. So real strides there is 0, then first, just double check on all this. Okay, all that shit still works, great. Put the upcast back, put that back, that's where the 2 upcasts land. Do you want to unroll first? We can do that. So it's like simpler. Put those at the end. Put that there. Let's say 5 and 6. All right. Okay, strides is none, then we do strides for shape. Okay, so that's the same. Why is back so crazy? That's just not right. Should be fine to unroll them first. Oh, it's just because these are not right. So we want to switch 2 and 5. So it's actually the same as before. We just add 6 and 7. It's easier to think about. Good. Okay, so it is correct. It's just stupid because these, the ones that have stride 0 here should also have stride 0 there. See, that should have stride 0. So that's that. It's kind of backwards. Doesn't matter what order I do it in. The locals actually do matter what order I do it in, which is annoying. It's the same thing, right? Okay, fine. Good. Good. So that 0 is there, and what? Yeah, that zero's there. Okay, fine. We shouldn't be checking that. That's so annoying that the locals matter. You see the problem with the locals, right? Whatever, we're just doing the other word, but the problem with the locals is like where the warp is depends on where the locals are. Is that slower or something? Great, it's slower, who cares? This should make any sense to anybody. We're doing the same thing that's in this blog post. We're just doing it in kind of a sustainable way, hopefully. More sustainable. Still not super sustainable. We'll get there. So these zeros can also apply to these. Wait, that's already there though. Oh, but because that's, no, it shouldn't be there. Oh, no, that's fine. Yeah, that should be 0 and that should go away. Yeah, okay, let's just manually write the strides. So we have 0, 0. Now it's a little hard to think about. So the ln is going to be 16. So this stride is ln times 4. This stride is 4. 0, 0, 0, 4. Sorry, 1. And this is the same thing? No, I put the 1 in the other place. That works. Yes. Great. Looks correct to me. Now we do 4 copies each. So is that what that's doing too? Load call and row, load BK. So they have 8 being loaded per batch. And we only have 4. Why is that? This is basically the same thing. We should figure out why they have 8 and we only have 4. Oh, because they're doing it in the warp. Oh, they do it in the warp and not the whole thing. Oh, that's annoying. Oh, that's, wait, what? Does that even work? No, I guess, okay, it is supposed to be shared across the whole thing. That's fine. Okay, I guess actually, no, the only reason it's different is because mine is, 2d6, but that's larger. I don't get it. Okay, thread tile. The wave is 32 by 16? Oh. Okay, so they're doing 32 then. Should be fine. Let's see if we break anything. That breaks it. That breaks it because the thing that it's swizzling to is unrolled 16. I don't think tinygrad supports that. I'm not even exactly sure what that means. this is where these things get tricky when like the shapes start to, but they're not usually actually different. This is annoying about how we express the TCs as well. All right, let's check this one on AMD. Let's check this one. What do they call it? Register tiling? So, okay, the whole idea with tinygrad is going to be to take each one of these tricks and figure out how to apply them and search across all of them. So we're doing register tiling, we're not doing LDS. So I hand-coded LDS for this, but eventually we're going to search across that. So things are going to get real fast. It's going to be this year. We're just going to look at all the CUDA kernels, see what tricks they're using, put the tricks into tinygrad, and then be faster than Torch. We have tons of bounties, by the way, for people who are interested in making our Torch backend better. Here's our Torch bounty section. So you can be a participant in making the Torch backend better, and then we can use Torch. There we go. There's the same kernel running on AMD. Why are we not getting the same speed as them? That's a good question. It's because this dumb thing they do with the warps that I don't know how to do. It's not dumb, I just don't know how to do it. Like they all do this. And before I need to really understand what it is. Because like tinygrad doesn't think about warps. We're not getting a lot of gigaflops. We're only getting 6,000 gigaflops. They're getting, wait, well, no, that's just with LDS. They're getting 22,000. Yeah, so I guess this is what I'm not totally understanding. The thread tile size is 4 by 4, but a wave is a block of 8 by 4 of the output matrix. Then they have the block tile size. All right, we gotta just really understand all this stuff because this isn't exactly matching what I'm doing. It's fine. There's like another place we can stick things into. This is, if I really understood what the tensor cores were doing, if I truly understood the tensor cores, this would all work, because I've done all these tricks for tensor cores. But I don't really understand the tensor core code. A bunch of people have refactored it after me, and it's like better now than it used to be. So we can also somehow like stick the upcasted thing in the stride unroll. Like the reason that thing didn't work was I'm just talking nonsense. A wave is a block. Where's block size defined? We get 256. So this is an LDS tile. Each thread now computes a 4x4 block. Thread tile. Since a wave, also, why isn't that grouped? That should be a float for store. I don't know why it's not. That'll make things a little faster, but that's not the major problem here. That should also be grouped. Why is nothing being grouped? All these loads should be grouped too. I have a lot of questions. There's so much gains to be made if I fix the devectorizer. It's clearly divisible. I don't know why they're not being grouped. Yeah, this should be a grouped float, load, and store. I don't know why it's not. These should all be grouped. LVM should support local. Okay, well, those are probably some minor things slowing it down, but we're still not totally understanding how their tiling works. We know we get the tiling right when these like tiles are the right size. So this is BK times, wait, that's the size I have. 128 times 8 is that, right? NB ITER wave M. Okay, WN 64 divided by 8 times 4, so that's 2. So wave tile. Oh. Yeah, we don't support that. Well, we sort of do. So those are like interesting.
is that done explicitly? Yeah, it must be 256 threads per work group, which is what I have as well. Arrange them into a 2x4 grid of wave tiles. Is that fake or is that real? It's called kernel 3 registers. Let's read it. I'll go to the computer to read it. All right, close that window. Yeah, that one VS Code server, great. Yeah, I don't have no time. I have forever. I can sit here and wait forever. We're still on this one here. Undersea regs. TM times TN is the thread tile size, so that's actually unrolled. That's like, yeah, like tinygrad doesn't really support this kind of output. This is the reduce loop. So first we iterate over BK blocks, which is this outer loop. But that's the only loop that we have. We populate the shared memory reads. So where's that number come from? NB reads B is Bn times Bk divided by block size, divided by 2d6. So that's 4, right? Because that's 128, and that's 4. So it is the same 4. B reads A is Bm times Bk divided by block size. Okay, so it's doing the same 4 reads then. That's fine. What size is it launching with? Block size. 256, 128, 128. So that's the same thing I'm doing. Well, it's 406 by 128, 64. That's 32. So they're doing something else. So BK times BM, so that is the same. They might be swizzling it differently, but that's a whole different thing. We can definitely do a swizzle there. We actually probably do want to do a swizzle there. We probably want to permute that, right? Because think about it. We can then coalesce the loads. It's probably a big advantage. Three, we're unrolled that many times. So sine wave n. Wave n just goes there. We cache A and B for the entire wave tile. So that just must be these reads here. I like that I can mouse over there. Okay, cool. So that's error constant. What? They're both 2. TM and TN are both 4. So this is... Oh, but that's okay. That's iterating over BK. And BK is, yeah, so that's 4. Okay, so that actually matches. They're just not unrolling that loop. Which would be really cool if we could not unroll it too, but I don't know if we know how to do that. I think the linearizer supports that. It's annoying to read unrolled. It's not like a problem that's unrolled, but like that could just be not unrolled. Okay, so maybe we actually are doing the exact same thing. So why the hell is mine so much slower? Oh, probably because of, yeah, look, they're flipping the index. So look how they flip the index, right? That's what I was talking about. So when they do those reads in, it flips the, yeah. So they store it locally flipped. Interesting. These piss me off. Those things too. Like it's just because the expressions used twice. Like these indexing expressions are used in 2 places, so it uses them twice. But yeah, so they're flipping. Which one do we want to flip? We want to flip data 1. Sorry, temp 0. But I think it's the same. Does it matter also which is LIDX0 and LIDX1? It's LIDX1, which is not the actual warp. That's LIDX0, which is... this is doing me out of line. It's not going to work because I broke something? Yeah, what did I break? I knew what I was breaking when I did that too. Okay, we don't want to actually check that. Let's just check 0 and 1. Oh no. Okay, fine. Is that faster? 340, a little bit, maybe. No, that's what I was saying. So at least, yeah, we're hitting LIDX0 there, which is actually that on those, which is good because it's all going to be coalesced. This shit's not going to be coalesced. Wait, it depends on... It's like kind of coalesced. Because that's, yeah, that's 4. That's probably not what we want. God, we just need to search this. Is that faster?
Oh, I feel like it was just as slow. Yeah, it's just as slow, doesn't matter. Am I getting a 90, 70? No. No, I got 6 red boxes to sell. I mean, we're making a lot of progress, but like, and AMD is the one who should really be thinking about this. Nobody wants these GPUs. I get 3 emails a week saying, please, can I buy a green box? Do you have one more green box? Hello, green box. And then I have 6 red boxes, and I haven't, I think maybe I sold one earlier in the year, or maybe it was 0. I forget. We had someone write in to try to return a red box. Like, it's just bleak. Yeah, it's sad there's no big RDNA 4, I know. And the chip would be so good too. With their double sending tensor cores. Oh, a big RDNA 4 would be great. But it is not to be. It's not like that bad. It does allegedly have 200 teraflops of FP16. Without any, I don't know how much more this Squid Game energy drink I can drink. Tastes like fake sugar. Someone find that die shot? It's like the breakdown. So this is how everybody thinks about this stuff with this register tiling. Because like I've seen this in other kernels before too. This is how Triton thinks about it. So like I don't know if it's just the right way or it's just how everyone thinks about it. Why is there no launch bounds? Oh, because I'm on metal. Yeah. By the way, I should. You can insert this for the driver. I don't know where it went. And then we get errors and interrupts. So there's a chance we're gonna make a tiny box out of 9070s, and then I'll buy some. But first, we gotta sell these. We're gonna probably by the end of the year, we're going to have this stuff figured out, and we'll have our torch back end to a pretty good point. Like, what I will say about this driver and what I will say about buying a red box is it's stable. It's not going to crash. And if you do find a crash in our driver, it's extremely simple and we will fix it immediately. And we actually have the ability to fix it, and we have the ability to test whatever the fix is in CI such that it won't happen again. And that's really more than can be said for AMD. AMD demonstrated very clearly when I would send them bugs that they had absolutely no idea how to fix them. And what they would do is they would just throw things at the wall until something got fixed. They'd flip flags around. Oh, hey, the day I realized that there was no hope was the day I got that thing back that explained that the in-order queue was causing problems, so they enabled the out-of-order queue. They got new AI-optimized internal test processes. Oh, great. Right? There's AI optimized ones now. The driver still crashes. I've still seen the driver crash plenty. Whereas, yeah, I haven't really seen the AM driver crash, and if things do crash, we can fix them. Yeah, this is about like bank conflicts and shit. I'm doing the swizzling slightly wrong. Yeah, no, I know, but we're getting there. We're getting there, and the something I realized, like you're not going to have to use tinygrad. You're going to be able to get this speed with PyTorch and Torch Compile. There's a $400 bounty now if somebody can get GPT fast outperforming with the AM driver. It shouldn't be hard. Like it's faster already if you use the R Llama stuff, but a lot of that just comes down to the AM driver. Like hip graph is just not fast. This bounty is like easy for $400. Coup de graph's actually pretty fast. It's not that fast. Envy is faster than coup de graph, but like coup de graph is usably fast. Hip graph is not. I don't know, like at what level. Again, a lot of the time it's just Carter cult. Like AMD would just, and you always think it's going to get better. You always think it's going to get better, and you can look at the kind of stuff Anush is tweeting, and you can see why it won't. Because what he's focused on, and almost everything he tweets is applications. This application, right? There's that Antoniax guy who's making the Nano GPT trainer run fast on MI300X, and you can do this. The problem is that isn't actually useful to people who have different applications. AMD talks about inference. Their thing is inference. This is not a good business to be in. Because the problem with inference is everybody can spend a lot of time coding their thing to fit on whatever weird inference accelerator they want, right? If you're going to be running the same model a million times, sure, put the software engineering resources into coding it for the absolute cheapest accelerator you can buy, and that's probably not going to be AMD. That's probably not even going to be something that looks like a GPU. That's going to be some ultra quantized. You can see this all happened 5 years ago with Tesla. So Elon got pissed at NVIDIA, and to be fair, NVIDIA went through a rough period around 2017 and made the FSD chip. Hello? It made the FSD chip, and the FSD chip is an inference chip. And if you're willing to code everything, it's totally fine. The minute Elon tries to make a training chip with Dojo, it pretty much fails. You don't hear about Dojo anymore because it failed, because he misunderstood what the problem was. The problem is not, can we make a chip that is amazing at this set of specifications? That's true for inference, but that's not true for training, and it's not true for research. Because researchers aren't going to use it. There's no, it's totally worth spending double the money to have the experience that's good. So yeah, inference is not a business, and then the application style of sales is not a way to sell AI accelerators. You have to build robustness. Quick aside, you guys want to check this out. So this is our MNIST trainer. It's the same MNIST trainer as always. But the key thing now is that we can see the graph. Our visualizer's gotten good enough. So not the first one, because the first one includes all the random kernel inits. But this one. So these are all the kernels that run for MNIST. Each of these green ones is a kernel. I'll show you the tensor graph. Tensor graph is pretty cool. So this is the tensor graph. These are all the tensors in a training step of MNIST. And the fact that this like works and loads. So you can like see like this here is a convolution, convolution weights, convolution input, multiply, reduce. This is a bias, right? We're doing the bias here, only on the channels, right? So it's NCHW. This is a ReLU. We don't use max for various reasons. Comp where. Yeah. So you can see the convolutions coming down. Then we go over here. We do the backwards pass. There's still a little bit of slowdown here. These should be merged into one. We need two reduces still to do a backwards conv. These might be speed up things though. So some of the two reduces are because it's faster to do two reduces, but again, it's got to be benchmarked. Yeah, and then you can come over here, and this is the Atom optimizer. So this is Atom. Here you can see like then it updates those numbers. I don't know if that's the learning rate. But yeah. This is picking the random indices. Oh, that's because this where here is because some of them might be out of range. We have the data, put the data in here, do the first conv. Oh, that's actually the ground truth. This here is the ground truth, and up here is the data. So you can see where the ground truth, follow that arrow, see where it goes into the loss function here. We can also like put boxes around these things to say what, well, if we look at the kernel graph, which we can also, I'm not sure it's going to work for this one because it's kind of big, but we can look at how the kernel graph gets formed. So these are all the different actual kernels that run on the device before they're top assorted. Yeah, we're making this work for like really big models too. Yeah, you wish you had this type of observability and everything, use tinygrad. Someone asked earlier what I think of the DeepSeek open sourcing stuff. DeepSeek writes infrastructure that looks like a hedge fund. And what I'll say about this is it's actually very good. So hedge funds, because they're in such a competitive space, the stuff that you like, they're the smart people to do it. And somebody needs to rug pull all of finance in America so that the people in America who are actually talented, like, I don't know, again, but it's just like maybe it's an incentives problem, but if you choose to go work on finance, like, what are you doing with your life? I don't know. I mean, maybe this does need to be enforced at the government level, and we just can't have the smartest people in America completely wasting their time playing this stupid zero-sum game against other people. The file system. Let's take a look at the DeepSeek file system. I think ours will be better. I think we can do better with the tinygrad. Like again, DeepSeek's infrastructure is very good if you are targeting like a use. It looks like hedge fund stuff. is this? Is this good? It's very complicated. Apple wrote this? Huh. I've never used this. All right, so they put their metadata in no, but like imagine instead of all the people wasting their lives at hedge funds, they wrote AI infrastructure instead. This is all stuff I don't know. Yeah, with split metadata and chunk. I mean, mini key value does that. I also wrote a distributed file system. It's a lot less sophisticated. It works at comma, and the only reason it really works at comma is because like this. We don't do any chunking. It's fine. The way like data being missing is also like if we lose like a route, it's not a big deal. So you know, it's just very simple. This looks a lot more complicated. But it's interesting that they're using it for like one of the most interesting things to come out of the DeepSeek thing is they explain what they're doing with key value. None of the other like OpenAI and Anthropic, you don't really know what they're doing with the key value store. It looks like they actually write the key value stores to disk. Just like crazy. Like they're syncing them out to disk. And then also, do we know what SSDs they're using? Did they ever talk about this? Oh, they're 14 terabyte. I know what they are then. They're the Samsungs. No. No, there's like aren't they? Well, they're not 14. They're like 14 point. They're probably these. Once I got the PCIe 5 ones. Yeah, it's this. So I don't know why they say 14. That'd be my guess. Whoa, they're 8 wide now? These are new, actually. I mean, it's probably the last gen. But it's like, this is what we use these at comma. Our older stuff is tons of
That's crazy.
Where do you see the thing about 16? On the README of 3FS. I'm very happy that they open source this. Like it's great to. What I hope, one of the things that really pissed me off in self-driving cars too, was that every company acted like they had some big secrets, and they didn't. We know they didn't because most of these companies are worth zero now. Most of these companies burned through billions of dollars, and all right. So again, I can't remember when Medium rugged us all. There was another. So you gotta, find the one that doesn't rank as high in Google's broken SEO. In 2019, when they are shut down, the employees will attempt to be absorbed into GM. So all of these companies had the same fake secrets, and they all they were wrong. It's so nice to have, and it takes a Chinese company to do it, which is another whole, why isn't this in America? What happened? America is all this shit came from America. All this AI comes from America. What's wrong in America that nobody can build infrastructure? Like nobody can build trains? It's the same problem. And it's not as good. This is almost always, if you see somebody open sourcing, there was just the Intel guy was posting that they won't open source Gaudi because of IP reasons. They won't open source or legal reasons. This is never really the reason. The reason is usually that the company is embarrassed about how bad the shit is. And that's why AMD doesn't open source their firmware. Notice how they never open source their MES firmware. They told me they were going to, they never did. And it's because it's embarrassingly bad. Almost always. Why things don't get open sourced. It's not because it's just like, well, who's going to put in the time to clean them up because the infrastructure is bad. This is the best infrastructure in the world. And it's so great that we get to see it. And now nobody can sit around and OpenAI has all this great secret. Like, no, they don't. They're losing tons of money. Look at the price difference between DeepSeek and OpenAI. Why is it so much cheaper? Also, Meta for Llama 4, I really hope you're making mixture experts. I'm surprised that, so mixture of experts is way better if you're running batch size 1. For larger batch size, it's a lot less important, but still, they're crushing it with it. So I really hope Llama 4 is going to be a big mixture of experts model. Because with a big mixture of experts model, you can beat DeepSeek. I know, we need to get our OE support better, yeah. We need to improve our mixture of experts support, and then one of these days, we'll write the thing that multi-threaded CPUs. What you really want to write for multi-threaded CPUs is like a runtime dispatcher that looks a lot like a GPU. So this is just using, and we use this too, right? This is the same. Like it's a U-ring stuff, right? We actually we have support for this in tinygrad. Our speed is pretty good. You guys can see it. So every tinybox comes with a 4-way RAID. Yeah. So this is like load a whole llama in. I think it's decent. We're getting 11 gigabytes per second from our disk array to the GPU. But we should be able to double that. I don't know why it's not double. I asked about that. It's IOU ring in user space because their FS is in user space. But yeah, I mean, it's still got to be passing it to IO ring in the kernel, though, right? It's not like they can be anywhere else. So kind of the improvements that I want to make. Like, this is still basically a generic key value store. I want everything to be hashed based on, like I want everything to be like a hash-based lookup. I want the key of everything to always be the hash. And it's still just like, it looks complicated. I have to set up this complicated database. I don't know. Like, it's not enough scale, I think, to require those things. There's a great section by an Anthropic engineer on Twitter on a single machine. It's a cool, talked to this guy at a party once. We talked about this. So it says basically like, can you fit Twitter on, yeah, one of their design requirements was have a pretty standard FS API. I have no interest in doing that. I want ours to just be basically Hugging Face. Like, what is Hugging Face? So we can like load any model and be able to cache key value stores. To be fair, yeah, sure, we're gonna have to hash them, but it should be fast. We should be able to get some cryptographic hash function that can run at GPU memory speed, and then I'm totally fine with just doing that. That's not much overhead to go to a disk. We'll pick some block size. We'll hash small blocks, use Merkle trees. It'll be good. We only have to write this stuff once. But we should definitely understand this, like, fully before we build a file system. This is a reason they built one. So yeah, I mean, we built one for comma. It's much simpler, though it's never the bottleneck. It's single machine write, like but it's not used hot like this. Yeah, it seems like their data center just like isn't all that big. They were talking in this README about the cluster consists of 180 storage nodes. So what's the size of this? It's 2.5 petabytes. This whole thing's like the same size as comma's cluster. No, hang on. There's gotta be something. Oh, I forgot a 16. Okay, no, it's bigger. That's 40 petabytes. Okay, so it is about 5 times the size of comma's cluster. We're gonna get to this size. How much is that gonna cost me? How much these drives? I'm sure it's these drives. I want this one. Yeah, that's fast. But why does that need 8? It doesn't need 8. 4 is fine. Is that speed? 4 should be fine. Wait, no, is it? No, okay. It's like barely not fine. What's that mean? Yeah. Oh, Twitter had some good engineering. Yeah. Twitter in 2014, 2015 had great engineering. You didn't see what happened to it over the next 8 years. What are these drives going to cost me? Is that a real price? Not too bad, actually. Is that real? What? I got the same price. That looks like though. Wait, Gen 4? No, this isn't the right drive. What? I still think these are the ones they're using. Let me try to work it out. So, okay, their aggregate read across the cluster is 6.6 terabytes a second. So 180, so that's 36 gigabit per, oh, 293 gigabit, so 293 gigabit, each has 16 drives, so it's 18 gigabit a drive, or, yeah, so it could very well be the, yeah, just 2.3 gigabytes per second, gigabytes per second per drive. So it's probably these drives. Thanks for getting them for me for. Yeah. It's a reasonable price for that many petabytes. It's doable. .500 client nodes were used. I mean, this is kind of interesting in and of itself. They actually use separate computers for storage nodes. So I don't really want to do that. I want to use the same computers. I want to just put a little storage on each computer. No,
have to pay for all the extra networking cards and switches and stuff, and just use PCIe switches with computers.
And then imagine each RAID array in a tiny box. Like imagine each 4 terabyte RAID array in a tiny box being like a chunk of memory.
I guess even, I mean, you could go even further and like, why is the RAID? I don't even want to use the RAID. Don't kill your IOPS. Just like every drive is just a thing. Every drive is just like a little bit of chunk of memory. You know, there's a mode on the EPYC processors which can like segment your memory per CCD, which is like you get crazy there with the. You guys know what NUMA stands for? But yeah, we're doing it right. That's an acceptable speed. Let's slow this time. Non-uniform memory access. Yeah, it's when you got little bits of memory stuck everywhere. Making NUMA work, memory abstractions are so much of like getting this stuff to be good. All right, back to this. So I think we were actually doing the right stuff. One of the things we can do. We want to permute them all. Yeah, this needs more thinking. Let's go back to the article. Okay, I think we actually did do this. I don't think we're doing anything wrong. We don't have this double buffering either. Oh, and then that's another hole. We can do that. We really just kind of need to support that opt-in beam. That's the right way to do this. Amanda's gonna be home from Temple, and then we're gonna go get dinner because I'm hungry. All I ate today was a Squid Game energy drink and yogurt and strawberries. So I think the project probably here is not to keep doing this. Like, it's there's just so many choices about how to do this.
many of these things can be permuted in many different ways, and I could sit here and I could manually write out all sorts of things. Or we can figure out what the core things are and figure out how to put them in search. And that's probably the right way to approach this. And probably the right way to approach that is refactoring the tensor core stuff. The tensor core stuff right now is still this bespoke code. It looks like TC equals 3 is broken. Okay, this logic's basically here. This has been refactored pretty nicely. But it's still not totally there yet. It's another annoying thing. Like this whole fix up AST function needs to be rethought. All these hacks for group for reduces, which is again doing stuff with the locals. This function needs to be rewritten and needs to be thought about what we actually mean when we talk about locals and local memory. There's like almost completely separate things happening here where we're doing load and stores from a chunk of memory that is then used later on. But as long as we permute these load and stores equally and we don't go into the axes that are, no, that's not really right. You want these axes to be full. So I'm putting that over there. You want, because you get this many threads. And that's, you can think about this load to store move like that many threads just going like boom. And then you can see it's upcasted 4 here, which is why you get that 4 here. Okay, the other bigger problem with that, why is my load coalescer not working? This shit should be coalesced. So should this. Why is this order not correct? Why is this one down here? It's doing that on both of them now. Yeah, I mean, that's a known problem too. But no, this should be load coalesced and fixed. We have this extra thread group barrier. There's so much to just deal with here. There's so many like inefficiencies in this kernel. Before we even try to do anything more complex, we have to be able to generate all the kernels that look like this highly reliably. This thread group barrier needs to go. This one should be up there. They should be ordered more appropriately. These should be coalesced into chunks. Yeah. Yeah, the devectorizer. The devectorizer needs to be fixed. Next week, we fix the devectorizer. I've been planning it for a while. It is time for the devectorizer to be fixed. Should also get rid of this. Like, why does it have the word temp here? Does someone want to do that refactor? It should not have the word temp. Can you just give it an arg the same way we do the arg for define global? And even that is an argument that it could be a unique op. But no, it's not a unique op. Unique ops are globally unique. But yeah, could someone get rid of the word temp from that? And make it the same as the globals? All right. So let's write a big list of to-dos. Grouping, I don't know how to spell coalescing. I need the new devectorizer anyway. The big thing I've been working on is TinyCorp got a contract to make the Qualcomm DSP fast. So I've been working on that. The Qualcomm DSP represents... So the Qualcomm DSP, GPUs are SIMT machines. The Qualcomm DSP is a SIMD machine. It's probably weird when I look over there. I should not. Why am I even looking over there? I can just move this stuff here. The GPU is a SIMT machine. The DSP is a SIMD machine, which makes it harder to use for a whole variety of reasons. It's good, but it's good that we have to support those. Also, it's a very wide 1 hour. An hour. So long. I don't know if I can wait. Should we wait for Amanda for dinner? Or should we go eat? We'll let non single instruction multiple thread. An hour? Don't do it. All right. Chat says I should wait. Thank you, thank you. Okay, fix load grouping. Fix extra barrier. Remove need for extra barrier. Fix load order to be in order. +0, 1 is last. It's good that we fixed that bug today by inserting that barrier here. Because if it's a loop, and you use barrier, if it's a loop and you use barrier inside the loop, you're gonna have to. So I'll get that merged. So good, we fixed the good bug today. Yeah, like these need to be grouped. definitely aligned. That's not the problem. Whether or not. Whatever. I'm rewriting all that code anyway. I hate that devectorizer. Okay. Remove extra barrier. Probably want to just like insert them, but doesn't have to be. Like they don't have to be the same. You don't know that until you're linearizing. Do you want to do that one now? We can probably do that one now. Fix load order to be in order. The 1, 0 is last. Yeah, that's fine. That problem still exists there. Okay, good. Yeah, it's a lot easier to like see here. But actually these aren't, you can't group those anymore. Instructions broadcast to multiple cores. I mean, that's what GPUs are. GPUs are SIMT machines. Oh, also, I don't know if there's a way on metal, but this, let's see if we can find out if there's a way on metal. Because that'd be a cool abstraction to add. Explore fast global global load to local store. What this is like, yeah, you're loading from this global and you're storing to that local. Wait. No, what happened here? Guys, we lost a few. This can't be real. What happened? What? No, that can't be right. Oh, because the strides. Oh, yo. Oh, I don't want strides there. There we go. All right, look, it's less terrible. Right, syntactic. Y is TC equals 3 broken for streaming. Sugar for these local additions plus use it in tensor core kernel.py. Oh, we're getting a lot of viewers now. We got 737 viewers. All right, I guess we got to keep going then. Keep going. We'll keep going till Amanda gets home. All right, we got viewers. Let's go. Squid Game energy drink. Squid Game energy drink. Oh, that shit gets nastier every sip. I thought it was only nasty for the first sip. Oh. Yo, imagine watching Squid Game energy drink. Imagine watching Squid Game while you're drinking Squid Game energy drinks. All right. Move extra barrier. right? Syntactic sugar. What else? What else we got? Yeah, we could save AMD for big booba. Yeah, that's good. That's good. Let's see if we can get rid of that extra barrier. Let's take a look. Since we got a lot of viewers, I think that's a good time to use Viz. Oh, we fixed that Viz bug today too, in the stupid Python HTTP server. All right, so this is like a representation of that kernel, and you can watch. What is it doing? Where are those blocks? She says hi. All right, so we're getting the loads and stores in here. Let's see if what it looks like here. Okay. So we have two barriers there. Oh, is this one like not? Why are there two barriers like that? Huh? Wait, what? What's going on? Is that a Viz bug? It's got to be a Viz bug. Am I making copies of them? That's annoying. See the Viz bug? Are some of them not tuples? They're all tuples. Why is that like? Oh, actually, that might not be a Viz bug. That might be something that actually happens. Okay, here we go. So yeah, they're both valid topo sorts. This is like a valid way to write this too. And it's interesting that the barriers are next to each other. So we have a bunch of like choices which tinygrad makes. Now this is not a Viz bug, actually, that's real. I have this thing called block reorder, and that's where a block reorder runs. So you can look at this is what it looks like non-block reordered. It almost looks better. We need to figure out what's going on to make it go the other way. We should always place barriers as soon as possible, I think. So this might just be fixable by, and we could do what's called peephole optimization. Yeah, I studied compilers in school. No, that's not a good choice. I don't have last? Is last the right place? Last is the same. Remember first, is that still correct? It didn't complain. Yes, that stores temp one. Okay, we definitely don't want to do that. Let's try this. So the order of these determine the top of sort order. No. Junk. Those are loads too, actually. So that's the problem. Yeah, that's the problem. Yes, that's what happens if we want to render the barrier as soon as possible. If we want to wait as long as possible to render the barrier, we get the other thing. We could combine them earlier into one barrier. That's an option. There's no real, there's no real reason that they're one barrier. It's not until we're linearizing that we start to do this. Okay, they're one barrier there. We could make barriers special in the linearizer. Do we want them to be? The linearizer is like what puts all the things in order. And then we have this extra function which reorders the block. Which is where a lot of those bugs are. This thing sucks. Put loads in the middle of the beginning of the block and prevent priority inversion. Like we could just delete one of those. I'm not happy about this. I feel like we can't merge the barriers because if we merge the barriers, it's like, yeah, you can't do that. Well, the parents. Let's think about that. Let's think about the order we want. By the way, this linearizer is a lot nicer than what used to be here for the linearizer, so be grateful. It could be worse. So this is the old order. The old order actually looks pretty good. can't really fuse the barriers there. No, actually, that's not really what we want to do. We want to dispatch all the loads early. The way I do this in RDNA is I having new ROPs and issued loop over old ops, append to new ROPs. Yeah. I don't know about that. I think this is D3. No, it's definitely not. But yeah, it's Dagray and D3. It's definitely not. We're definitely not writing a graph layout library. Someone's written good ones. No, I mean, the performance of this is impressive. The performance of JavaScript in general is impressive. No, there are some bugs in Viz sometimes, depending on like how it stores the UOPs, but I think most of them are fixed now. So this is not a Viz problem. We reorder the things. Yeah, I mean, this is definitely better than the old linearizer, but yeah, okay, so this barrier can technically go there. We definitely want to place barriers as late as possible, but not after global loads. All right, I can write some stupid hack for it. Okay. Change nothing. Change nothing. I want to put them before the loads. We have to make it more negative. Oh. I do what I want. There we go. Yeah, okay, so those things depend on the barrier. Okay, we have the priority inversion thing. All right, that makes a lot of sense. Cool. So that's fixed. Now, why does that work and that doesn't? We can do a people optimizer too. That's pretty easy. Replace pairs of barrier with one barrier. Oh, it always has lamp there. Check that. Is it wrong? Non-type object has no argument CTX. Oh, don't use X. Ugh, it's stupid that I use X. I shouldn't use X. Fine. Okay, one barrier. Is it any faster? Looks slower. Great work, team. Oh no, we're just on AMD. Okay. All right. Done. Why is that one showing up last and yet that one shows up first? That's interesting. So that top of sort function is nice, whereas in all sort orders should be valid. I don't understand though why. Sometimes that's less. Oh, because that's that. And this is a shift. All right, let's just throw in, ready for a hack? I know how to write a hack for this. With my minus 1,000. Yeah, okay. What? That doesn't make sense. It's a load. All load should have 2. What? How is that wrong?
a lot of low. Oh, it's index. I forgot it's index. Ugh. It's probably wrong sometimes. I hate this bullshit. Oh, totally wrong. Whatever, it's not more readable. No, see, we want to make that index higher. Penalize those index. Yeah, we're just gonna be overloaded by the load priority. Whatever. Alright, that's a pain to fix. What to go there? Why is that one there and that one there? I don't like the max of the index. True. Why is it true? Oh, that? True? Object is not callable. Go there. Like, you see the problem, it should be +0, but there isn't a +0. This one orders earlier because it's a special op. Oh, maybe if I just put shift. This is crap. Yeah. That fixes it. Alright, that's easy. Put add last. Move it down there. It's usually an easy fix if you think about these things enough. Put down there with its friend sub. Yeah. Would have thought that would matter. Alright, good. Look, they're in order now. It's after like nulls and stuff too. None of that stuff should ever do indexing, so just do the add last one, that's fine. Yeah, that's pretty, right? Like, that's what it should look like. I don't know if it's any faster, but... It looks more beautiful. I'm a big fan of that. I think it's really important that things look beautiful.
Priorities have to be outsourced to renderer groups? I don't know about that. Well, we're not at any of that fancy stuff yet. I'm just trying to get like LDS stuff working. Oh, let's explore the async stuff. This is a Monday project. All week next week, I just got to work on the devectorizer. I can't work on the torch backend. I just gotta fix that. Should we look into why TC3 is broken? Yeah, we probably should. This one's gonna crash. Apple's driver crashes sometimes, by the way. Oh, come on. How nice is this NVIDIA driver? This AMD driver. Oh, beautiful. 12 gigabytes per second. Not 24. That's copying, by the way, that's copying 16 gigabytes off the disk. No, you want to use a fast kernel? You gotta write fast equals 1. If you just do that, it should be the fast kernel. Yeah, it's fast. Look at that. 40 gigaflops. 40 teraflops even. 43 teraflops. So yeah, that's the fast kernel. This is not the fast kernel. Hello! We're on stream if you want to say hi.
Hi.
The camera's
Are
there.
they here?
They're all here. We got 708 people.
Wow. I had the craziest day.
Wow, meditation seems exhausting.
It was so fun. Not up your alley, but definitely up mine.
Wow.
Silence the whole time.
Yeah, you seem out of breath.
I ran up the steps.
Oh, the steps are pretty exhausting. That's not
Cameras
live. You want to see the live one?
Yeah, let's see the live one.
There we go.
Oh, wow.
Yeah.
They don't want to hear about the temple.
They like my haircut, so you know that makes one of
I like your haircut.
Oh, look what we drank.
Oh, yeah.
The Squid Game energy drink.
Was it good? What's it?
Some energy drinks are nasty on the first sip and get better as you drink it.
This is gross.
I would have to say that don't take my Squid Game energy drink.
You can have it.
I would have to say that this one was the opposite.
Yeah, it's disgusting.
Tastes like sugary bubble gum.
Ugh. All right.
I'm hungry.
Yeah, I know.
Yeah, we'll go eat food.
We can go get food.
I had to make myself lunch. It was very hard.
Thank you for telling him to wait for me. I appreciate it.
You think they're over there, but they're not.
I know, I'm just reading the chat.
I know.
I'm
It's
curious
a
what they're
problem.
saying.
So I used to use that camera. We can bring the chat over here. I used to use that camera, and it like, kind of made
Okay,
sense.
great. Let's see what they say.
They think you're pretty.
That's so nice of them.
I know.
I didn't say any words all day.
Wow.
Noble silence.
Wow.
Have you heard of the noble silence? You wouldn't like it there.
I said a lot of words today.
Yeah, I was in silence all day.
Yeah.
And then we did an eating meditation, and you're supposed to chew your food until it's liquid, which was interesting. It took like 2 hours to eat lunch. You would hate it.
I'm just imagining all the wear on your teeth.
But we hiked up to the Big Buddha, which was cool.
Are you a spy? They think you're a spy.
For which agency?
Yeah.
Which?
Are you thinking?
A
Are you
cool
thinking? Mossad, maybe?
Are we
you
talking?
thinking
Well,
CIA?
what country? America.
Five Eyes? She works for what's the one in England?
At least I don't work for the Canadian one.
Wait, the Royal Canadian Mounted Police are very legitimate.
I just
And-
wanna work for a really competent one where everyone's like super high quality.
Fashion models agency.
Mm,
Mm,
that's nice. How does it feel to date a spy? Oh, that's a question for you.
that's where we're going. From
How do you
here.
feel?
You know,
Unawares?
the thing about spies is you have to ask how far you can throw them. Like sometimes, remember that time the US was going to connect a cable with Hong Kong, but then they canceled the cable because the people were going to steal the data. But in reality, you think Facebook and Google are going to sponsor a cable where the data goes that way? No, the data goes that way. And spies can be dealt with in the same way.
How am I gonna be dealt with?
Oh, just the other way. It's like remember that time.
So you're getting the information.
Remember
from me.
the time that in Future's End when Henry Starling, when their Voyager's trying to uplink his communication database, and he reverses the uplink, and he's like, oh, you're only from the 24th century, and all this time I thought you were from the 29th. I'm going to eat food. Thank you for watching my stream today, everybody.
Bye. Nice to see you guys again.
Bye.